Hello there and welcome to Life Beyond Seen, where the oldest questions have a way of drifting quietly to the surface, the way something long submerged eventually finds its way back to the light. Tonight, we're going somewhere that exists in two worlds at once, a city that is still alive, still ringing with temple bells and filled with the smoke of incense and the footsteps of millions of pilgrims, and a city that may also lie beneath the sea, drowned and silent, waiting at the bottom of the Arabian Sea in a darkness that human eyes have barely touched. This is the story of Dwarka, or rather, it is two stories, maybe three, layered on top of each other the way sediment layers on the ocean floor, each one pressing down on the one before it. There is the mythological Dwarka, described in ancient Sanskrit texts as a city of gold and wonder, built by a god and swallowed by the sea. There is the archaeological Dwarka, a real ancient port city that researchers have been carefully excavating for decades. And then there is the Dwarka that lives in sonar images and carbon dates and scientific controversy, a possible city beneath the Gulf of Khambat that, if the most dramatic interpretations are correct, would rewrite what we think we know about the earliest chapters of human civilization. We're going to take all of this slowly tonight. The ocean does not hurry, and neither should we. But before we go any further, I want to ask you something simple. Where are you right now? Are you in a warm room somewhere? The kind where the light is low and the blanket is close? Are you near the sea or far from it? Somewhere in the middle of a continent where the nearest coast is hours away? Maybe you're in India, and this story feels close to home in a way it might not for everyone else. Or maybe you're somewhere entirely different, and you came across this the way curious people often do, following a thread of interest through the night. Whatever the case, I am glad you are here. If this kind of quiet, careful exploration is something you enjoy, I would be genuinely grateful if you like this video or subscribe to Life Beyond Seen. It helps this channel find more people who appreciate a slower kind of wonder. And now, make yourself comfortable, because the sea has something to show us. The modern city of Dwarka sits on the western tip of the Saurashtra Peninsula, in the state of Gujarat, India, right where the Arabian Sea meets the Gulf of Kutch. It is a city that has been inhabited in one form or another for a very long time. Pilgrims have been coming here for centuries. The Dwarkadish temple, dedicated to Krishna, stands near the waterfront, a 5-story limestone structure rising above the shoreline, with a spire that can be seen from a considerable distance. The temple is thought to have been built around the 16th century, though it sits on the site of much older structures, and its foundations are believed to be ancient. Inside and around it, there is the constant sound of bells, the smell of marigolds and incense, the movement of people who have travelled far to be here. It is a living, breathing, sacred place. One of the 7 most holy cities in Hinduism, in fact. Standing at the waterfront in Dwarka, you can watch the sea. It is not a gentle sea. The tides here are strong, the currents active, and the water carries a heaviness to it, a kind of restless energy. Fishermen have worked these waters for generations. Pilgrims come to the ghats to stand at the edge of the water, to offer prayers toward it, to touch it. There is something in the relationship between this city and the sea that has always felt charged, as if the two are in some kind of long, slow conversation. And part of that conversation, according to the ancient texts, involves loss. Because the story that has been told about Dwarka for thousands of years is not a story of triumph or permanence. It is a story of a city that was built, lived in, loved, and then taken back by the ocean. The texts describe it in specific terms. A city that was built on land reclaimed from the sea, a city of extraordinary beauty and scale, a city associated with the god Krishna. And when Krishna departed from this world, the sea returned to claim what had been given. The ocean moved in, slowly and then completely, and the city was gone. This is the myth, or at least that is one way to describe it. But here is what makes Dwarka different from most mythological cities. The texts that describe it are not vague. They do not speak in the abstract language of allegory alone. They name geography, they describe coastlines, they mention specific events in sequence. They describe Arjuna, one of the great heroes of the Mahabharata, standing on the shore and watching the sea advance. They describe the water moving through the streets. This is not the kind of myth that is clearly metaphorical. It reads, in places, like a record. And that is where the scientific questions begin to enter. Now, roughly 30 to 40 meters beneath the surface of the Arabian Sea, in the waters off the coast of Gujarat, something was found. Not by treasure hunters or myth seekers, but by researchers conducting routine scientific surveys. What they found in those sonar images were structures, geometric patterns, shapes that appear regular in a way that natural formations typically are not. Walls, or things that look like walls, grid-like arrangements that suggest deliberate construction. The ocean floor in that region, in at least two separate locations that are often discussed in the same breath, but are actually quite distinct, appears to contain the remains of something built by human hands. Whether those hands belong to the people of a civilization older than any we currently recognize, or whether the sonar images are being interpreted too generously, or whether the truth is somewhere more complicated in between, that is the question at the heart of everything we're going to explore tonight. It is worth pausing here for a moment just to sit with the scale of what is being suggested, not by fringe theorists, but by researchers working within institutions, publishing findings, giving press conferences. The suggestion is that beneath the sea off the coast of India, there may be the remains of a city. A real city. One that was inhabited by real people, perhaps thousands of years ago, perhaps many thousands of years ago. A city that was eventually swallowed by rising sea levels at the end of the last ice age, and that has been lying on the ocean floor ever since, while the world above it changed beyond recognition. And the reason this is not immediately dismissed as fantasy is that the geology supports the basic premise. Sea levels at the end of the last glacial maximum, roughly 12,000 years ago, were significantly lower than they are today. The coastline of Gujarat extended further west. Land that is now underwater was once dry. Rivers that now empty into the sea once flowed across plains that are now the seabed. This is not speculation. This is established geological fact. The question is not whether the sea rose and covered land. It did. The question is whether people were living on that land, and whether any evidence of those people has survived beneath the water. The Gulf of Kambat, also known as the Gulf of Cambay, cuts into the western coast of India south of the Kathiawar Peninsula. It is a shallow, turbulent body of water with some of the strongest tidal flows in the world. The sediment load in the Gulf is enormous. Visibility underwater is, in many places, essentially zero. It is not a comfortable or welcoming body of water, and yet it is here, in December of 2000 and January of 2001, that a team from the National Institute of Ocean Technology conducted a sonar survey of the seafloor, primarily looking at sediment distribution and pollution levels. They were not looking for ruins, they were doing environmental science. What the sonar returned was not what anyone expected. The images showed large geometric structures on the seafloor, roughly 40 kilometers off the coast of the city of Surat. Regular shapes, what appeared to be walls, what looked like a grid, and running through it all, what seemed to be the course of an ancient river now buried beneath the sea. The structures were at depths of around 30 to 40 meters, and when material was dredged from the site, some of what came up was extraordinary. A piece of wood that was later carbon dated to approximately 9,500 years ago, pottery, animal bones, a human tooth, stone that appeared to have been worked. When the Indian government's then Minister for Science and Technology, Murali Manohar Joshi, announced the findings in May 2002, the story became international news almost immediately. The claim being made, at least in the most enthusiastic versions of the announcement, was that this could be the oldest city ever discovered. Older than Mesopotamia, older than the Indus Valley civilization, older than almost anything in the archaeological record. A city from before the dawn of what we currently call history, the scientific community responded with significant skepticism, and for reasons that were entirely reasonable. The method of recovery was dredging, which is essentially dragging a device along the seafloor and scooping up whatever it catches. Dredging does not preserve context. It does not tell you which layer an artifact came from. It mixes material from different depths and different time periods. A piece of wood from 9,500 years ago could have been carried to the site by a river and deposited there naturally, with no connection whatsoever to any structure on the seafloor, and the sonar images, while striking, were being interpreted through a lens of expectation. Geometric patterns in sedimentary rock are not unusual. Fracture lines, erosion features, and tectonic activity can all produce shapes that look, to an eager eye, like the remains of walls and streets. None of this means the structures are not there. It means that the evidence, as gathered, was not sufficient to confirm what the most dramatic claim suggested, and that distinction matters enormously. There is also a separate site closer to the modern city of Dwarka, where a different and more carefully conducted set of investigations had been underway since the 1980s. The marine archaeologist S.R. Rao led excavations near the shore at Dwarka for years, working with the Archaeological Survey of India. His team found stone anchors, pottery, structural remains, and a small seal with a three-headed animal motif. These finds were dated to roughly 1500 BCE, placing them within the Late Bronze Age. Rao believed, based on his findings, that Dwarka had indeed been a real and significant port city in antiquity, one that had been partially submerged by the sea over time. These two sites, the inshore excavations near the modern Dwarka temple and the deeper offshore sonar discovery in the Gulf of Kambat, are frequently discussed as if they are the same thing. They are not. They are separated by hundreds of kilometres, by very different depths, by very different methods of investigation, and by very different levels of scientific credibility. One of the things we will try to do tonight is keep them distinct, because conflating them does a disservice to both. What they share, though, is a central mystery, and that mystery is this. Beneath the waters of the Arabian Sea, off the coast of a land where one of the world's oldest continuous civilizations developed, there appears to be something old, something built, something that has been sitting on the ocean floor while the world above it forgot it was there. The modern city of Dwarka continues its life above all of this. The temple bells ring at dawn and dusk. The pilgrims arrive by bus and train and on foot. The sea moves against the stone ghats with the same indifference it has always had. And somewhere beneath the surface, in the murky, sediment-heavy water, in the darkness where the tides push and pull and visibility falls to almost nothing, there are questions that have not yet been answered. How old is what lies beneath? How was it built, and by whom? Is it the city the ancient texts describe, or is it something else entirely, something that does not fit neatly into any existing story? And what would it mean for history, for archaeology, for our understanding of how far back the story of human civilization actually goes if the most dramatic interpretation turned out to be correct? These are the questions we're going to carry with us through the rest of this journey. But to understand them properly, we need to start at the beginning. Not the geological beginning, not the sonar survey of the year 2000, but the much older beginning. The one written in Sanskrit, the one passed down across thousands of years in the form of epic poetry and sacred text. Because before this became a scientific question, it was a story, and the story is worth knowing in full, because it is more specific, more detailed, and more geographically grounded than most people realise. The myth, it turns out, has always contained something that looks a little like a memory. The story begins, as so many of the oldest stories do, not with a discovery or an excavation or a sonar image, but with a text. With words copied carefully from older words, passed through generations of scribes and scholars and oral tradition until they arrived, more or less intact, into the world we inhabit now. The texts that describe Dwarka are among the oldest literary sources in the world. The Mahabharata, the Vishnu Purana, the Harivamsa. These are not casual documents. They're vast, layered, complex works that took shape over many centuries, drawing on older oral traditions that stretch back further still. And within them, the story of Dwarka is told with a specificity that tends to surprise people who encounter it for the first time. Most people, when they think of ancient myths about lost cities, imagine something vague, a golden place, a paradise swallowed by divine punishment, a story with no particular geography, no timeline, no cause and effect. The myth of Dwarka is not like that. It has a builder, it has a location, it has a length, it has a reason for its construction, a period of occupation, and a specific mechanism of its destruction. It is, in that sense, less like a fable and more like a chronicle. Whether it is a chronicle of something real is the question, but the detail itself is worth sitting with. According to the texts, Dwarka was built by Krishna, the eighth avatar of Vishnu, one of the most central figures in Hindu theology and mythology. The story goes that Krishna's people, the Yadavas, were living in the city of Mathura, on the banks of the Yamuna River in northern India, and were under constant threat from a powerful king named Jarasandha, who attacked Mathura 17 times. Rather than continue fighting a war that was destroying his people, Krishna decided to relocate the entire Yadava clan to a new city, one that would be safer, one that would be built on the sea. He asked the god Vishwakarma, the divine architect, to design and construct it. He asked the ocean god Varuna to grant land for its foundation, and from the sea itself, 12 yojanas of land were said to have risen to receive the new city. 12 yojanas. The yojana is an ancient Indian unit of measurement, and its precise modern equivalent is debated, with estimates ranging from roughly 7 to 15 kilometres, depending on the period and the source. So 12 yojanas would place the city somewhere between roughly 80 and 180 kilometres in extent, which is an enormous range and not particularly useful for pinning down an exact size. But the point is that the texts are trying to give a measurement. They are not saying Dwarka was large in a vague mythological way. They are saying it had a specific dimension, even if that dimension is now difficult to convert precisely. The city described in the texts is extraordinary by any standard. The Harivamsa describes it as having streets of gold, palaces studded with gems, gardens filled with flowering trees, and a harbour capable of receiving ships from distant lands. The Vishnu Purana adds that it was 12 yojanas in length, surrounded by walls and equipped with roads, markets and public spaces. It had towers and gates. It was, in the language of these texts, a city worthy of the gods. Which is, of course, exactly what you would expect a sacred text to say about the city built by an avatar of Vishnu. The grandeur is part of the story's purpose, but beneath the grandeur there is geography. There is a western coastline, there is a sea, there is a harbour. These are not invented details in the way that golden streets might be. They are the kind of details that suggest the story is anchored to a real place, even if the embellishments are layered thickly over whatever real memory might lie beneath. Krishna ruled from Dwarka for many years. The Mahabharata places him there throughout much of its central narrative, the great war between the Pandavas and the Kauravas, the conflict that forms the backbone of the entire epic. Dwarka in these texts is not a marginal city. It is a seat of power, a place of counsel, a city that matters to the political and spiritual world of the story. And then, after the war ends and Krishna himself dies, something changes. The Mosala Parva is the 16th book of the Mahabharata. It is a short book and a dark one. It describes the end of the Yadava clan, who destroy themselves in a drunken civil conflict after a series of omens and curses. Krishna is killed shortly after, struck by an arrow from a hunter named Jara who mistakes his foot for a deer, and then the ocean comes. The text describes what happens in the aftermath of Krishna's death with a directness that is striking. The sea, which had given land for Dwarka's construction, now reclaims it. The ocean floods the city. It happens within 36 years of Krishna's passing, as had been prophesied, and Arjuna, one of the great heroes of the Mahabharata, is there to witness it. He has come to Dwarka to escort the surviving inhabitants to safety, and the text describes him watching as the sea swallows the city behind them, street by street, building by building. The water rising, the walls disappearing, the city that had been built from the sea returning to it. This is not a vague catastrophe. This is not a flood sent by an angry god in a general, symbolic sense. It is a specific event, described in a specific text, involving a specific geography, a specific timeline, and a named witness. Arjuna watches the sea take Dwarka. The Mausalapava records it. And the location, on the western coast of India, at the edge of the sea, corresponds to the place where the modern city of Dwarka still stands today. Now, it is worth being careful here. The Mahabharata is not a historical document in the way that modern scholarship uses that term. It is a vast epic poem with mythological, theological, and didactic purposes. It contains gods, divine weapons, miraculous events, and figures who live for centuries. The Mausalapava itself is full of omens and supernatural signs. The submersion of Dwarka in the text is part of a larger narrative about the end of an age, the Dvapara Yuga giving way to the Kali Yuga, the current age of the world in Hindu cosmology. The flooding is not simply a geological event in the story, it is a cosmic one. And yet, the specific detail of a coastal city being swallowed by the sea on the western coast of India is not the kind of detail that typically appears in purely invented mythology. Flood myths exist in many cultures, but they tend to be global in scope, or at least regional. A story about one specific city on one specific coastline being reclaimed by the sea in a specific time frame is a different kind of story. It has the texture of something that was remembered, even if it was also transformed by centuries of retelling. What makes this tension genuinely interesting, rather than simply frustrating, is that we know coastal flooding of exactly this kind did happen along the Indian coastline. This is not a matter of speculation. After the end of the last ice age, roughly 12,000 to 10,000 years ago, sea levels around the world rose dramatically as the great ice sheets melted. In the Indian Ocean and the Arabian Sea, the rise was between 100 and 120 metres over several thousand years. The coastline of Gujarat extended significantly further west than it does today. Land that is now beneath the sea was, 10,000 years ago, dry ground. Rivers flowed across it. People lived on it. And as the sea rose slowly over centuries, that land disappeared beneath the water. This is established geological fact. It is not mythology. It is not speculation. The sea did rise. The coast did change. Land that existed once is now submerged. If people lived on that land, and they almost certainly did, then the memory of losing it to the sea could have persisted. Stories have carried memories of real events for a very long time. There are indigenous oral traditions in Australia that appear to encode memories of coastline changes that occurred more than 7,000 years ago. The idea that a story about a city swallowed by the sea might preserve some fragment of a real geological event is not far-fetched. It is in fact consistent with what we know about how human memory and storytelling work over long timescales. The Mahabharata as it exists today was likely compiled and written down between roughly 400 BCE and 400 CE, though it draws on much older oral traditions. The events it describes are generally placed by scholars in a period somewhere between 1500 and 3000 BCE, though this is itself contested. The submersion of Dwarka as described in the text would fall within that range, but if the story contains a memory of actual sea level changes, the events being remembered could be considerably older, reaching back into the period of post-glacial flooding that reshaped the Indian coastline thousands of years before the text was written down. This is where the line between myth and possible memory becomes genuinely blurry. not in a mystical sense, but in a practical historical one. The question is not whether the Mahabharata is literally true in every detail. It is not. The question is whether, embedded within its narrative, there is a real geographic memory, a recollection, however transformed, of a real place that was really lost to the sea. And that question cannot be answered by reading the text alone. It requires looking at what is actually on the sea floor. What is also worth noting is that the ancient texts are not alone in describing Dwarka's submersion. The tradition is consistent across multiple sources. The Vishnu Purana, the Harivamsa, the Bhagavata Purana, all of them carry versions of the same event. The sea reclaims the city. The detail varies slightly from text to text, as you would expect from a tradition transmitted across many centuries. But the core event is stable. A great city on the western coast built by Krishna, swallowed by the sea after his death. This consistency across independent textual sources is itself a point of interest. It does not prove anything happened. But it does suggest that the story of Dwarka's submersion was not invented by one author for one purpose. It was part of a shared tradition, repeated and preserved across different texts and different periods. There is also a detail in the Mausala Parva that tends to get overlooked in popular discussions of Dwarka. When Arjuna comes to the city to help the survivors evacuate, the text describes the sea advancing while he watches. The ocean takes the city gradually, not in a single catastrophic wave. It rises and fills the streets. This is not the language of a tsunami or a divine punishment from above. It is the language of inundation, of water rising slowly over land, which is, of course, exactly what happens during sea level rise. Slowly, over time, not all at once. The fact that the text describes this process as gradual is a small but interesting detail, because it is geologically accurate in a way that a purely invented flood story might not be. None of this proves that the city described in the Mahabharata is the same as whatever lies on the seafloor off the coast of Gujarat. The texts describe a city of gold and gems, built by a divine architect, inhabited by the clan of a god. The archaeological record, when it eventually catches up to the seafloor, will not find gold streets. It will find stone, pottery, anchors, walls, the ordinary physical residue of people who lived and worked and traded. What the texts and the seafloor might share is not the grandeur, but the location, the coast, the sea, the fact of submersion. And if they do share that, then what we have is something rare and genuinely significant. A story that has been told for 3,000 years in a language that is still read and revered today, that may contain at its centre a real geographic memory. A city that was real, in a place that is real, lost to a sea that did exactly what the story says it did. That possibility is what has driven decades of investigation. It is what brought S.R. Rao into the water near the Dwarkadish temple in the 1980s, running his hands along stone walls in near zero visibility. It is what prompted the National Institute of Ocean Technology to take a second look at their sonar data in 2001. It is what continues to draw researchers, writers, and curious people back to this question, even when the scientific answers remain incomplete. The myth does not resolve the archaeology. The archaeology does not confirm the myth, but they are in conversation with each other, and that conversation is one of the most interesting ongoing dialogues in the study of ancient India. Before we can go any further into what the seafloor actually shows, and what the investigators who went down there found, we need to understand who those investigators were, what conditions they were working in, and what they brought back from the water. Because the story of how Dwarka has been studied is almost as fascinating as the story of what may have been found there. The first person to bring serious, systematic scientific attention to the question of Dwarka's underwater remains was a man named Shikarippa Ranganatha Rao. He was not a young adventurer looking for headlines. By the time he turned his attention to the waters off the Gujarat coast in the early 1980s, SER, Rao was already one of India's most respected archaeologists, known primarily for his excavations at Lothal, one of the major Indus Valley civilization sites. He understood stratigraphy, he understood material culture, and he understood the difference between a compelling story and a defensible finding, which is precisely why his work near Dwarka matters as much as it does. Rao was working under the Archaeological Survey of India, the government body responsible for the protection, excavation, and study of India's cultural heritage. The SI had been aware of the possibility of submerged remains near the coast of Dwarka for some time. Local fishermen and divers had occasionally reported unusual stone formations in the shallow waters near the temple, and there were enough references in the textual sources to make the site worth investigating properly. So in 1983, Rao and his team began what would become a series of underwater excavations that continued into the early 1990s. It was slow, careful, methodical work. Nothing like what would come later with the Gulf of Kambat announcement. The site they were investigating was not in deep water. The inshore excavations near the modern Dwarkadish temple took place in relatively shallow conditions, mostly within a few meters of the surface, along the seafloor just off the coast and in the tidal zone. But shallow does not mean easy. The waters off Dwarka have their own challenges. Tidal currents run strong through the area, and the visibility underwater is often extremely poor. Sediment stirs constantly, and the seafloor is a tangle of natural rock formations, modern debris, and whatever older material might lie beneath. Working there requires patience, physical endurance, and a tolerance for uncertainty. The divers on Rao's team often found themselves feeling their way along stone surfaces rather than seeing them clearly, identifying shapes by touch as much as by sight. What they found across those years of patient work was genuinely significant. Among the most important discoveries were stone anchors, not one or two but a substantial collection, recovered from the seabed near the Dwarkadish temple site. These were triangular stone anchors, a specific type known from the late Bronze Age and associated with maritime trade across the Arabian Sea. The triangular form is not random. It is a functional design that held well in sandy and rocky seabeds, and examples of this type have been found at other ancient port sites across the region. Finding them concentrated near Dwarka was a strong indicator that the site had once functioned as an active harbour. There was also pottery. Sherds recovered from the underwater deposits near Dwarka showed characteristics consistent with pottery traditions from the period between roughly 1500 and 3000 BCE. This is a wide range, but it placed the material firmly within the time frame of the Indus Valley civilization and its aftermath, the period when the texts suggest Dwarka was a functioning city. Pottery is one of the most reliable tools in an archaeologist's kit. It changes in recognizable ways over time, and its presence in a specific layer tells you something real about when people were using that space. But perhaps the single most discussed artifact from Rao's inshore excavations was a small stone seal. It was found in the underwater deposits near the temple site, and it bore an engraving of a three-headed animal. This kind of seal, with its incised animal motif, was consistent with the seal traditions of the late Harappan period, the final phase of the Indus Valley civilization. Seals of this general type were used in trade contexts, often as markers of identity or ownership. Finding one at a submerged coastal site near Dwarka added a layer of material credibility to the idea that this location had been inhabited and commercially active during a period that overlapped, at least in general terms, with the time frame suggested by the ancient texts. Rao published his findings, and his conclusion was measured but clear. He believed that the underwater remains near Dwarka represented the physical remnants of a real port city, one that had existed on the Gujarat coast and had been progressively submerged as sea levels changed and the coastline shifted. He was careful not to claim that he had definitively found the city of Krishna. That would have been a theological and mythological claim, not an archaeological one. What he argued was that Dwarka had been a real settlement, a real port, with real material culture, and that its remains were now underwater. This was already a significant finding. It is worth pausing here to appreciate what Rao and his team were actually doing physically during these excavations. Underwater archaeology is not like land archaeology, where you can set up a grid, take your time, photograph every layer, and return tomorrow if you run out of daylight. Underwater, you're working against the clock in a much more immediate sense. Each dive has a time limit. The water near Dwarka, particularly in the tidal zone, has windows of relative calm between the strong tidal flows, and those windows can be frustratingly short. A diver might have 20 or 30 minutes of workable conditions before the current picks up again, and visibility drops to almost nothing. In those minutes, they need to record, measure, photograph if possible, and recover samples. Then they surface, wait, and go back down. The visibility issue deserves particular emphasis. People who have not worked in these waters sometimes imagine underwater archaeology as something like swimming through a clear aquarium, peering at ancient stones in gentle filtered light. The reality near Dwarka is quite different. The sediment in the water column can reduce visibility to a metre or less on a bad day. Divers describe working in conditions where they can barely see their own hands. They navigate by feel, by memory of the site's layout built up over many dives, and by the careful use of guide ropes and marker systems laid out on the seafloor. It is painstaking, physically demanding work, and it requires a particular kind of mental composure to remain productive when you cannot see clearly and the current is tugging at you. Despite these conditions, the inshore excavations produced a coherent picture. The structural remains near the Dwarka temple site included what appeared to be walls and platforms made of dressed stone, arranged in ways that suggested deliberate construction rather than natural formation. The stone had been worked, shaped to fit together. There were indications of what might have been a harbour structure, possibly a jetty or a seawall. The overall impression, from the accumulated evidence of the anchors, the pottery, the seal and the structural remains, was of a coastal settlement that had been actively used during the Late Bronze Age and had subsequently been submerged. Rao estimated that the site had been occupied somewhere between 1500 and 3000 BCE, based on the material culture recovered. This range is broad, but it is consistent with what the texts describe, at least in general terms. The Mahabharata's account of Dwarka places it in a period that scholars generally associate with the late Harappan or post-Harappan era, roughly the 2nd millennium BCE. The material Rao recovered did not contradict this. It was not proof of the mythological Dwarka, but it was evidence of a real place, in the right location, from roughly the right period. The scientific community received Rao's findings with cautious interest. His methodology was sound, his conclusions were measured, and his publications went through the appropriate channels. Some researchers questioned whether the structures he identified were truly artificial rather than natural rock formations, a debate that is common in underwater archaeology and not unique to this site. Others felt the pottery and anchors were compelling but not conclusive in isolation. But the work was taken seriously, which is the appropriate response to careful science. What Rao's inshore work established above all was that the question of Dwarka was not merely a matter of religious tradition or mythological speculation. There was something physically real in those waters. The debate was no longer about whether to take the idea seriously. It was about what, precisely, was down there, how old it was, and how it related to the stories that had been told about this coastline for thousands of years. There is something quietly remarkable about the image of Rao's team working in those waters in the 1980s. The Dwarka temple stands on the shore above them, its tower visible from the sea, its bells audible when the wind is right. Pilgrims move through the temple complex above, following a tradition of devotion that stretches back many centuries. And below the surface, a few metres down, archaeologists are running their hands along stone walls in murky water, trying to understand what those walls are, when they were built, and who built them. The sacred and the scientific occupying the same space, separated only by the water line. It is also worth noting what Rao's work did not claim to find. He did not announce that he had discovered the golden city of the Mahabharata. He did not hold a press conference to declare that the legend of Krishna's Dwarka had been confirmed. He published his findings in academic form, described what the evidence showed, and acknowledged what remained uncertain. This restraint matters because the story of Dwarka's investigation does not always maintain that level of care in the years that followed. The inshore findings were real, documented and defensible, but they were also, in a sense, modest. A port city from the Bronze Age is historically significant, but it is not the kind of announcement that makes international headlines. For that, the story needed to move offshore, further from the coast, deeper into the sea and considerably further into controversy. The inshore excavations near the Dwarkadish temple had established that something was there. They'd given the investigation a solid, if incomplete, foundation. But the findings that would capture the world's attention in the early years of the 21st century came from a different location entirely, discovered by different people, using different equipment for a completely different original purpose. And the way that discovery was handled would raise a set of questions that are still being debated today. The shift from Rao's careful inshore excavations to the far more dramatic claims of the Gulf of Cumbat is not just a change of location. It is a change of character in the story. One is the slow, methodical accumulation of evidence by a trained archaeologist working within established scientific frameworks. The other is something faster, louder, and considerably more complicated. Understanding the difference between these two strands of investigation is essential to understanding why the question of Dwarka's underwater city remains genuinely unresolved, and why that unresolved quality is not simply a failure of effort or interest, but a reflection of how difficult this particular question actually is to answer. Because what was found in the Gulf of Cumbat, and what was claimed about it, and what the scientific community said in response, is a story in itself, a story about the gap between discovery and proof, between sonar images and excavation, between announcement and verification. It begins with a survey that was not looking for a city at all. In December of the year 2000, a team of researchers from the National Institute of Ocean Technology, known as NIOT, set out into the Gulf of Cumbat aboard a survey vessel. Their purpose had nothing to do with archaeology. They were not looking for lost cities or submerged ruins or evidence of ancient civilizations. They were conducting a routine environmental survey, studying sediment patterns, water quality, and the general geological character of the seabed. The Gulf of Cumbat, which opens southward into the Arabian Sea along the western coast of Gujarat, is an industrially active stretch of water. It sits between the Kathiawar Peninsula to the west and the mainland to the east, and its floor carries the accumulated record of centuries of river sediment, tidal movement, and geological change. Understanding that floor was a practical matter of environmental management. Nobody on that vessel was thinking about the Mahabharata. The equipment they were using was side-scan sonar, a technology that works by sending out fan-shaped pulses of acoustic energy to either side of the vessel and recording how those pulses bounce back from the seafloor. The return signals are assembled into images, long strips of acoustic shadow and reflection that reveal the texture and shape of the bottom in considerable detail. Side-scan sonar is a standard tool in oceanographic survey work. It does not touch the seafloor. It does not collect samples. It sees, in a sense, by listening. And what it began to show, the NIOT team as they moved through the southern portion of the Gulf of Cumbat, was something that did not fit the expected picture of a sediment-covered seabed. The sonar images showed geometry, not the irregular organic shapes that characterize natural seafloor features, not the gentle undulations of sand dunes or the chaotic scatter of rock formations, but something that suggested regularity. There were what appeared to be long straight lines. There were right angles. There were patterns that, when assembled into a composite image, looked like a grid. A large grid spread across a considerable area of the seafloor, at depths of roughly 30 to 40 metres, located approximately 40 kilometers off the coast of Surat. The survey team continued working through December 2000 and into January 2001, and the images accumulated. The more they looked, the more the geometry seemed to hold. There was also what appeared to be a paleo channel, the remnant course of an ancient river running through the area. This was not surprising in itself. River channels from periods of lower sea level are known features of submerged continental shelves. But a river channel running alongside what appeared to be structural geometry was a different matter. Word of the findings moved through the relevant institutions over the following months. The NIOT submitted its data, the images were examined, and the question of what exactly had been found began to generate serious internal discussion. In May of 2002, that internal discussion became very public, very suddenly. Murli Manohar Joshi, who was then India's Minister of Science and Technology, made an announcement. He declared that the NIOT survey had discovered the remains of a lost city in the Gulf of Kambat, a city that might date back 9,500 years or more, a city that might be the legendary Dwarka of Krishna. The announcement was made at a press conference. It was carried internationally. Headlines appeared across the world. Some were careful, many were not. The phrase, "Lost City of Krishna," travelled far and fast, and the story took on a life that the sonar images alone could not fully support. It is worth pausing here to note something important about the sequence of events. The announcement was made in May 2002. The sonar survey had been conducted in late 2000 and early 2001. In the intervening period, there had been no controlled excavation of the site. No trained diver had descended to the seafloor at the location and physically examined the structures. No peer-reviewed paper had been published presenting the findings to the scientific community for evaluation. The announcement preceded all of that. It preceded the kind of verification process that normally sits between discovery and declaration. This is not an unusual situation in the broader history of sensational archaeological claims, but it matters enormously for understanding how the Dwarka debate developed in the years that followed. The story got out before the science had finished its work, and in some ways it never quite caught up. What the NIOT team had done in the months between the survey and the announcement was to conduct dredging operations at the site. Dredging involves lowering a collection device to the seafloor and dragging it along the bottom to bring up material. It is not excavation. It does not preserve the spatial relationships between objects. It does not record stratigraphy, meaning the layered sequence of deposits that tells archaeologists what came from when and where. Dredging is, in the language of archaeology, a destructive method. It collects material, but it destroys the context that gives that material meaning. What was brought up from the Gulf of Kambat site through dredging included a range of items. There were pottery sherds, there were what appeared to be worked pieces of stone, there were animal bones, there was a human tooth, and there was a piece of wood. That piece of wood became the centre of the dating controversy. It was submitted for radiocarbon analysis, and the results came back with a date of approximately 9,500 years before the present, placing it around 7,500 BCE. If that date was accurate, and if that wood was genuinely associated with the structures visible in the sonar images, the implications were extraordinary. The Indus Valley Civilization, the earliest complex urban culture known from the Indian subcontinent, dates to roughly 2600 to 1900 BCE. A settlement at 7,500 BCE would predate it by 5,000 years. It would place organised human habitation in this region at a time when, according to the standard archaeological record, the subcontinent's population was still composed of hunter-gatherer and early agricultural communities. It would not just rewrite the history of India, it would substantially alter the global understanding of when and where complex civilization first emerged. The problem was the dredging. Radiocarbon dating tells you how old a piece of organic material is. It does not tell you where that material came from, how it got to the place where it was collected, or whether it was ever associated with the structures nearby. In a dredged sample from a geologically active seafloor, A piece of wood could have washed in from anywhere. It could have been carried by river currents from far inland and deposited on the seabed centuries or millennia after it died. It could have come from a different depth than the structures. It could have been mixed with material from a completely different period. The dredge does not know the difference. It takes whatever is within reach and brings it up together, regardless of whether those things were ever in the same place at the same time. This is the fundamental problem with the Gulf of Kambat evidence, and it is not a minor technical quibble. It is the central issue that prevents the dating from being scientifically reliable. A date of 9,500 years is not inherently impossible. As we will explore later, the sea level history of the region makes it entirely plausible that there was dry land in the Gulf of Kambat at that time. But plausible is a different word from demonstrated. The wood fragment cannot be used to date the structures unless there is a documented, verified in situ association between them, and that association was never established, because no controlled excavation was ever conducted at the site. The pottery sherds were similarly problematic. Pottery can be dated by its style, its composition, and its manufacturing technique, but only when it comes from a known context. Pottery pulled up by a dredge in a geologically complex seabed, mixed with material from unknown depths and unknown origins, is very difficult to date with confidence. Some of the sherds were examined and described as consistent with known types from the 3rd to 2nd millennium BCE. Others were harder to classify. None of them could be placed with certainty in the context of the structures seen in the sonar images, because the dredge had not been deployed with the precision required to establish that kind of connection. The human tooth was perhaps the most intriguing single item. Human remains from a submerged site, if they could be properly dated and placed in context, would be remarkable evidence of habitation. But again, the dredging method made it impossible to know where exactly the tooth came from, how old it was in relation to the surrounding material, or whether it was associated with the structures at all. A tooth could survive in a marine environment for a very long time. It could have arrived at the site through any number of processes that have nothing to do with the city. Without controlled excavation, it remained an interesting object without a reliable story. The announcement made by Minister Joshi in May 2002 presented these findings in their most optimistic light. The language used at the press conference, and in much of the subsequent media coverage, treated the sonar images as confirmed structures and the radiocarbon date as a reliable indicator of the site's age. The result was a wave of international excitement that was, in retrospect, considerably ahead of what the evidence could actually support. Newspapers described the discovery of a 9,000-year-old city. Some accounts framed it as proof of the Mahabharata. The story moved through the internet, through popular books, through documentary productions, and through the broader cultural conversation about India's ancient past in a way that was difficult to slow down or correct. Researchers who tried to introduce nuance into the discussion found themselves in an uncomfortable position. Questioning the announcement could be read as dismissing the possibility of a significant find, or as being unsympathetic to the cultural and religious importance of Dwarka to millions of people. But accepting the announcement at face value meant endorsing claims that had not been subjected to the verification process that science requires. The space between those two positions was narrow and not particularly comfortable to occupy. Several archaeologists and geologists attempted to occupy it anyway, pointing out that the sonar images were intriguing but not conclusive, that the dredged material could not be reliably associated with the structures, and that the dating, while not impossible, was not established by the evidence as collected. These voices were present in the record, but they were quieter than the headlines. What the NIOT discovery did accomplish, regardless of what the structures ultimately turn out to be, was to bring the question of submerged sites in the Gulf of Kambat into serious scientific and public discussion. The sonar images were real. The geometric patterns were real in the sense that the sonar recorded them. Whether those patterns represent artificial construction or natural geological formation is a separate question, and it is one that cannot be answered by sonar images alone. but the images were enough to make a compelling case that something was worth investigating properly. The tragedy, in a scientific sense, is that the announcement in 2002 may have made that proper investigation harder to conduct, not easier. When a site becomes associated with extraordinary claims before those claims have been tested, the scientific community tends to approach it with heightened skepticism. Funding becomes politically complicated, and the signal-to-noise ratio in the public conversation makes careful research more difficult to communicate. There is also something worth saying about the original purpose of the survey. The NIOT team was not looking for a city. They found something unexpected while doing something else entirely. This is not unusual in the history of discovery. Some of the most significant finds in archaeology and geology have come from people who were looking for something completely different. The accidental nature of the discovery does not diminish its potential significance. If anything, it adds a kind of quiet drama to the story. A routine environmental survey, conducted in murky industrial waters, using acoustic technology designed to map sediment, and somewhere in those returning sound waves, the outline of something that did not belong to the natural seafloor. Whether that something is a city from before recorded history, a natural geological formation that happens to look geometric or something in between, is not nothing. The Gulf of Kambat was not the same after those sonar images were assembled. The question it raised was real, even if the answer remained out of reach. And so the situation as it stood in the years following the 2002 announcement was this: a set of dramatic sonar images, a radiocarbon date that was extraordinary if reliable and unreliable by the standards of proper excavation, a collection of dredged artifacts that could not be placed in secure context, and an announcement that had generated far more heat than the underlying evidence could comfortably sustain. The scientific community was sceptical, for reasons that were methodologically sound. The public was fascinated, for reasons that were entirely understandable, and the site itself sat at the bottom of the Gulf of Kambat, 40 kilometres offshore, at 30 to 40 metres depth, in water conditions that made direct investigation extraordinarily difficult. The structures, whatever they were not going anywhere. But understanding them was going to require something that had not yet happened. A serious, sustained, methodologically rigorous effort to go down and look. What stood in the way of that effort was not simply a lack of will or interest. It was the nature of the site itself, and the particular challenges of conducting science in one of the most difficult underwater environments on the planet. So let us look more carefully at what the dredge material actually was, and why the question of what it meant became so contested so quickly. When the NIOT team recovered samples from the Gulf of Kambat site, they were working with a method that is common in oceanographic and geological surveys but deeply problematic for archaeology. Dredging involves lowering a collection device to the sea floor and dragging it across the surface to gather whatever material happens to be there. It is useful for understanding the general composition of a seabed. It is not useful for understanding the relationship between objects. When you dredge, you're essentially reaching into a room in the dark, grabbing a handful of whatever your hand touches, pulling it up, and then trying to figure out what kind of room it was. The problem is that the handful might contain things from completely different times and places, mixed together by currents, by sediment movement, by the simple physics of how material accumulates on a seafloor over thousands of years. There is no way to know, from the material alone, what was next to what was above what, or what arrived when. The wood fragment was the most discussed piece of material recovered. It was sent for radiocarbon dating, and the result came back as approximately 9,500 years before the present, placing it around 7,500 BCE. That date, if it accurately reflects the age of the site, and not just the age of a piece of driftwood that happened to settle in the area at some point in the past, would be extraordinary. It would push back the timeline of organised urban settlement in South Asia by several thousand years. The Indus Valley Civilization, which is the oldest well-documented urban culture in the region, dates to roughly 3300 BCE, at its earliest phases, with its mature urban period beginning around 2600 BCE. A settlement at 7500 BCE would predate that by more than 4,000 years. It would be older than the earliest cities in Mesopotamia. It would sit in a period when most of the world's human population was still living in small, mobile hunter-gatherer groups. The implications, if the date were reliable and associated with actual construction, would be significant enough to rewrite several chapters of human prehistory. But here is the problem, and it is not a small one. Carbon dating is a precise and well-understood technique when applied correctly. What it measures is the decay of carbon-14 isotopes in organic material. It can tell you how old a piece of wood is, or a piece of bone, or a fragment of charcoal. What it cannot tell you is where that piece of wood came from, how it got to the location where it was collected, or whether it has any relationship to the structures nearby. A piece of wood that is 9,000 years old could have been carried by a river, deposited by a flood, buried in sediment for millennia, and then exposed by erosion at the surface of the seabed. It could have nothing to do with any human construction. Without stratigraphic context, without knowing the exact layer of sediment from which it was recovered, without being able to compare it to other datable material from the same location, the date is a data point without an address. It tells you something existed at that age. It does not tell you what or where or why. Several archaeologists made this point clearly in the years following the announcement. Graham Hancock, who is a popular writer rather than a credentialed archaeologist, and who was enthusiastic about the Kambat site, pointed to the date as strong evidence of a very ancient civilization. Professional archaeologists who responded were careful to explain that the date and the structures were two separate questions that had not been shown to be connected. Shireen Ratnagar, a prominent Indian archaeologist, was among those who noted that the recovery method made the material scientifically unusable for the purpose of dating the site. She and others pointed out that the NIOT team's announcement had conflated the sonar images, the dredged material, and the radiocarbon date into a single narrative that the evidence could not actually support. The pottery sherds recovered through dredging presented similar problems. Pottery is one of the most reliable dating tools in archaeology because different periods and cultures produce pottery with distinctive characteristics, clay compositions, firing techniques, and decorative styles. If you find a potsherd in a controlled excavation in a known stratigraphic layer, associated with other material from the same context, it can tell you a great deal. But a potsherd recovered through dredging from a mixed seafloor deposit is hard to interpret. Some of the sherds recovered from the Kambat site were described as consistent with pottery from known periods of Indian prehistory, but without controlled context, this consistency is suggestive rather than conclusive. The sherds could have arrived at the site through river transport, through sediment mixing, or through any number of other processes. The animal bones raised similar questions. Bone survives in marine environments under certain conditions, and the presence of animal bones at a site is consistent with human habitation, since people butchered animals and discarded the remains near where they lived. But bones can also arrive at a location through natural processes. Rivers carry organic material. Currents redistribute it. A bone that is found on the seafloor of the Gulf of Kambat could have originated anywhere within the drainage basin of the rivers that empty into it, which includes a very large area of western India. The human tooth was the most evocative of the recovered items. It was a molar, and it was described in some accounts as belonging to a human adult. If it did, and if it was genuinely associated with the site, it would be a direct and moving piece of evidence. A tooth is a human presence in a way that a stone or a potsherd is not. It is easy to imagine when you hear about it a person who once lived in this place, who walked on ground that is now 30 meters underwater, who ate meals and had a name and was part of a community that built something. That imaginative connection is real and it matters. But the scientific question is whether the tooth can tell us anything reliable about who lived there, when they lived there, and whether they had anything to do with the structures on the sonar images, and the honest answer is that, recovered through dredging, it cannot. What made the controversy particularly difficult to navigate was that the people raising scientific objections were not arguing that the site was unimportant or that no further investigation should be done. They were arguing the opposite in a way. The objections were essentially a plea for proper methodology. If this site is as significant as it might be, then it deserves a proper investigation, not a rushed announcement based on incomplete evidence. The concern was that the premature framing of the discovery as a 9,000-year-old city would make it harder, not easier, to conduct the kind of careful science that might actually resolve the question. There was also a political dimension that is worth acknowledging, because it shaped how the announcement was received and how the subsequent conversation unfolded. Dwarka has deep significance in Hindu tradition. The idea that an ancient city, possibly the city described in the Mahabharata and associated with Krishna, might be confirmed by modern science carried enormous emotional and cultural weight. For many people, this was not simply an archaeological question. It was a question about the depth and antiquity of Indian civilization, about whether the texts that had been passed down for thousands of years contained real memories of real places. That is a meaningful question, and it deserves to be taken seriously. But the desire for a particular answer is not the same as evidence for that answer, and conflating the two tends to make everything harder. Scientists who express skepticism sometimes found themselves accused of cultural dismissiveness, or of being unwilling to accept that Indian civilization might be older than Western scholarship had previously recognized. This was an uncomfortable position to be in, and it is worth noting that the skepticism was methodological rather than cultural. The issue was not the age of Indian civilization. The issue was whether this particular evidence, collected in this particular way, could support the claims being made for it. The radiocarbon date of approximately 9,500 years also deserves one more moment of attention, because it is not inherently implausible in a geological sense. This is actually one of the more interesting aspects of the story. At around 9,500 years before the present, sea levels in the Arabian Sea were still rising significantly from their post-glacial low point. The Gulf of Kambat, which is relatively shallow, would have had large areas of dry or near-shore land that were being progressively inundated as the centuries passed. It is not geologically impossible that people were living on land that is now under 30 to 40 metres of water. What is impossible, given the current state of the evidence, is to say with confidence that the structures seen in the sonar images are what those people built, or that the wood fragment was part of those structures, or that the site as a whole represents a coherent urban settlement rather than a collection of unrelated objects on a geologically complex seafloor. The distinction between something being possible and something being demonstrated is the core of the scientific objection. It is a distinction that matters enormously, not because scientists are unimaginative or uninterested in extraordinary possibilities, but because the history of science is full of cases where an exciting possibility turned out to be something more mundane, and also full of cases where careful, patient investigation eventually confirmed something that had seemed incredible. The Kambat site has not yet been subjected to the kind of investigation that would allow it to join either category. It remains in a third category, genuinely uncertain, genuinely interesting, and genuinely unresolved. What the 2002 announcement did accomplish, despite its methodological shortcomings, was to establish the Gulf of Kambat as a site of serious interest. The sonar images were real, the geometric patterns were documented. The dredged material, however imperfectly recovered, suggested that organic and cultural material was present in the area. None of that was fabricated. The question of interpretation, of what those patterns represent and what the material means, remained open, and the scientific community's response, while skeptical of the specific claims, did not entirely close the door on the possibility that something significant was there. Several researchers in the years following the announcement called for a properly funded, properly designed investigation of the site. They outlined what such an investigation would need. controlled excavation rather than dredging, in situ documentation of artifacts before they were moved, stratigraphic recording to establish the relationship between different layers of sediment and material, direct diver inspection of the structures to determine whether they showed signs of tooling or construction, and multiple dating methods applied to material recovered from known contexts. These were not unreasonable requests. They were in fact the minimum requirements for any archaeological investigation that hoped to produce reliable results. The difficulty was that the Gulf of Kambat is one of the most challenging underwater environments in the world for this kind of work, and that challenge, which is a physical and logistical reality rather than a political or methodological one, is the next part of this story. Because understanding why the evidence is still incomplete, why the debate has not been resolved in the 2 decades since the announcement, requires understanding what it actually takes to work in water like that, and what it costs in time and visibility and human endurance to try to do careful science at the bottom of a sea that does not make anything easy. So let us spend some time with the scientific objections themselves, because they deserve more than a brief mention. The skepticism that greeted the Gulf of Kambat claims was not casual dismissal. It came from people who study ocean floors and sedimentary geology for a living, and the concerns they raised were specific, technical, and grounded in what is actually known about how this part of the world behaves geologically. The first and most fundamental objection was about the sonar images themselves. Side-scan sonar is a useful tool. It produces images by bouncing sound waves off the seafloor and recording the returning signal, and it can reveal large-scale features of the bottom that would be impossible to see any other way. But sonar images are not photographs. They show shape and texture in a way that requires careful interpretation, and that interpretation is always shaped by what the person looking at the image expects to see. When you're looking for a city, geometric patterns start to look like walls. When you're looking for a riverbed, a long depression starts to look like a channel. This is not dishonesty. It is a known limitation of human pattern recognition, and it is precisely why sonar images alone are never considered sufficient evidence in marine archaeology. What the critics pointed out was that the Gulf of Kambat is geologically active in ways that produce exactly the kind of angular, regular-looking formations that can be mistaken for human construction. The Gulf sits in a region of considerable tectonic complexity. The Indian subcontinent's northward movement and its collision with the Eurasian plate have created a network of fault lines across Gujarat and the surrounding seabed. Fracture patterns in sedimentary rock along fault lines can produce strikingly geometric shapes. Parallel lines, right angles, grid-like arrangements. These are not rare geological features. They occur in multiple places around the world, and they have fooled careful observers before. Geologists who examined the sonar data pointed out that the patterns visible in the Gulf of Kambat were consistent with what you would expect from fractured sedimentary rock in a tectonically stressed region. That does not mean the patterns are definitely geological. It means they could be, and that without direct physical inspection of the features, there is no reliable way to distinguish a naturally fractured rock formation from a man-made wall using sonar alone. The shapes look similar. The sonar signal looks similar. The difference, if there is one, lies in details that sonar cannot resolve. Tool marks, mortar, deliberate shaping, the presence of material that does not belong in a natural formation. Those details require eyes, or at minimum a camera at close range. There is also the question of erosion. The Gulf of Kambat experiences some of the strongest tidal currents in the world. The tidal range in parts of the Gulf can reach 11 or 12 meters, which is extraordinary. That means enormous volumes of water are moving in and out of the Gulf twice a day, and they are carrying sediment with them. Over thousands of years, this kind of hydraulic energy reshapes the seafloor continuously. It scours rock, deposits sand, moves material, and creates features that can look, from a distance, like constructed geometry. Erosion by strong tidal currents is known to produce elongated ridges, channels, and platforms that have clean, almost architectural edges. Again, not proof that the Kambat features are natural, but a strong reminder that nature, given enough time and energy, is capable of producing shapes that surprise us. One geologist whose work is relevant here, though he was not writing specifically about Kambat, is the broader community of researchers who study what are sometimes called erosional landforms in tidal and estuarine environments. The literature on this subject is extensive, and it makes clear that the visual appearance of a seafloor feature is a poor guide to its origin. Regular shapes, straight edges, and repeating patterns are not reliable indicators of human construction. They are in fact fairly common products of geological processes operating over long timescales. The oceanographic objections were equally serious. Several researchers noted that the Gulf of Kambat is not just geologically complex. It is also one of the most sediment-laden bodies of water in the world. The rivers that drain into it, including the Sabarmati, the Mahi, the Narmada and others, carry enormous quantities of suspended sediment. The tidal currents keep that sediment in almost constant motion. The result is that the water in the Gulf is, for most of the year, extraordinarily turbid. Visibility near the surface can be just a few meters. Near the bottom, where the sediment concentration is highest, visibility can drop to essentially zero. This is not a minor inconvenience. It is a fundamental obstacle to the kind of investigation that would be needed to evaluate the structures properly. When the NIOT survey was conducted, the team used sonar rather than visual inspection precisely because visual inspection in those conditions is nearly impossible. The sonar could penetrate the turbid water and produce images of the seafloor regardless of visibility. But sonar, as already noted, has its own limitations. The combination of poor visibility and sonar-dependent investigation meant that by the time the announcement was made in 2002, no human eye and no camera had actually seen the features being described as walls and structures. The images existed. The interpretation of those images as human construction did not yet have physical confirmation. This point was made repeatedly by marine archaeologists who commented on the discovery. In underwater archaeology, the standard of evidence for identifying a site as man-made requires direct physical inspection. You need to be able to see the material, to examine its surface, to look for evidence of tooling or intentional shaping, to assess whether the arrangement of stones or other material makes sense as construction, rather than as natural deposition. None of that had been done at Kambat. The announcement was based entirely on sonar imagery and on dredged material that could not be reliably associated with the structures. The dredging itself drew sustained criticism. When the NIOT team recovered material from the site, they used dredging equipment which essentially scoops up sediment and material from the seafloor without any systematic recording of where exactly each item came from or what its relationship was to surrounding material. In controlled archaeological excavation, the precise location of every artifact matters enormously. The depth at which something is found, the layer of sediment it comes from, what is above it and below it, what other objects are nearby, all of these things together constitute the context of a find, and context is what allows archaeologists to interpret what they are looking at. A piece of pottery found in a specific layer of sediment can be dated and associated with other material from the same layer. The same piece of pottery scooped up in a dredge, mixed with material from multiple depths and locations, tells you very little. The wood fragment that produced the 9,500-year carbon date was recovered by dredging. There is no way to know where in the sediment column it came from, whether it was associated with any structure, or whether it was simply a piece of ancient wood that had drifted or been deposited on the seafloor by entirely natural processes. Wood is preserved in waterlogged sediment for very long periods. Ancient wood on a seafloor is not unusual. Finding a piece of 9,000-year-old wood in the Gulf of Kambat tells us that 9,000-year-old organic material is present in the area. It does not tell us that 9,000-year-old people built anything there. Several archaeologists made the additional point that the Gulf of Kambat is the kind of environment where material from very different time periods can end up in close proximity. Strong tidal currents move sediment and the objects within it. Material deposited thousands of years apart can be reworked and redeposited together. The seafloor is not a simple layered record of time passing. It is a dynamic, constantly rearranged environment where the stratigraphic relationships that archaeologists depend on can be disrupted or destroyed entirely. This makes the Gulf an extremely difficult place to do the kind of archaeology that produces reliable chronologies. It is also worth noting that the human tooth recovered by dredging, which received considerable attention in the coverage of the discovery, was not analysed in a way that produced clear results about its age or its association with anything else at the site. A human tooth is an evocative find. It suggests human presence. But a single tooth recovered by dredging from a turbid seafloor, without any context, cannot be used to establish when people were at the site, what they were doing there, or whether they had any connection to the geometric features seen in the sonar images. What is interesting about all of these objections is that they are not arguments against the existence of submerged prehistoric settlements in the Gulf of Kambat. They are arguments against the specific evidentiary basis for the claims made in 2002. The critics were not saying that the site was boring or unimportant. Several of them were quite explicit that the Gulf of Kambat, given its geological history and the known patterns of post-glacial sea level rise in the region, was exactly the kind of place where submerged prehistoric sites might be found. The sea level history of the Arabian Sea is well documented, and it makes the general idea of submerged habitation in this area entirely plausible. What the critics were saying was that plausibility is not evidence, and that the specific claims being made had not been supported by the kind of investigation that would make them credible. There is a version of this story in which the scientific community's response looks like institutional conservatism, a reflexive resistance to an uncomfortable idea. And it is true that science has sometimes been slow to accept discoveries that challenge established frameworks. But the Kambat case does not fit that pattern particularly well. The idea of submerged prehistoric settlements was not, by 2002, a radical or fringe concept. Archaeologists had been documenting and studying submerged sites around the world for decades. The North Sea's Doggerland, the submerged landscapes of the Persian Gulf, the drowned coastlines of Australia, these were all established areas of research. The scientific community was not resistant to the idea of submerged habitation. It was resistant to accepting that a specific site was a specific thing without adequate evidence. That is a different kind of resistance, and it is in fact how science is supposed to work. The frustration, for those who believed the Kambat site was genuinely significant, was that the methodological objections felt like they were being used to indefinitely defer a proper investigation. If the evidence collected so far is insufficient, the obvious response is to collect better evidence. If dredging is inadequate, the solution is controlled excavation. If sonar images are ambiguous, the solution is direct visual inspection. The tools for a more rigorous investigation existed. What was needed was the funding, the political will, and the logistical capacity to use them in one of the most challenging underwater environments in the world. And that last part is where the situation becomes genuinely complicated, in a way that has nothing to do with ideology or politics or cultural sensitivity. The Gulf of Kambat is not just a difficult place to work in, it is, by most measures, among the most difficult underwater environments for archaeological investigation anywhere on Earth. The visibility problem is severe and chronic. The tidal currents are powerful and fast-moving. The sediment load means that any excavation would immediately begin to be filled back in by settling particles. The tidal windows during which conditions are calm enough for careful work are narrow. These are not problems that can be solved simply by wanting to solve them. They require specific equipment, specific techniques, and a sustained commitment of resources that has not yet materialized, and so the site has remained in a kind of suspended state. The sonar images exist, the dredged material exists, the carbon date exists. The scientific objections exist, and the conditions that would allow a definitive investigation to be conducted remain formidably difficult to meet. What has emerged in the years since 2002 is not resolution, but accumulation. More questions, more context, more understanding of what the site might be and what it would take to find out. The geological story of the region, which is actually one of the more compelling parts of this whole question, goes some way toward explaining why the idea of a submerged settlement in the Gulf of Kambat is worth taking seriously, even if the specific evidence gathered so far falls short of proof. Because the sea level history of the Arabian Sea is not in dispute, and it tells a story that makes the general premise of the Dwarka legend not just mythologically interesting, but geologically coherent. To understand why the geological story matters here, you have to go back a long time. Not a few centuries, not a few millennia. You have to go back to the end of the last ice age, to a period that geologists call the last glacial maximum, when the ice sheets that covered enormous portions of the northern hemisphere were still locked in place, and the world's oceans held significantly less water than they do today. At the peak of the last glacial maximum, roughly 20,000 years ago, sea levels globally were somewhere between 100 and 120 metres lower than they are now. That is not a small difference. 100 metres is roughly the height of a 30-storey building. Applied across the shallow coastal shelves of the world's oceans, that difference in sea level translates to enormous areas of land that were simply above water. Land that people could walk on, settle on, build on and live on. Land that is now, depending on where you're looking, somewhere between a few metres and several hundred metres beneath the surface of the sea. In the Arabian Sea and the Gulf of Kambat specifically, the consequences of that lower sea level were dramatic. The Gujarat coastline, which today meets the Arabian Sea at a particular line that we treat as fixed and permanent, extended significantly further west. The Gulf of Kambat itself, which is today a roughly triangular inlet of the Arabian Sea, would have been substantially different in shape and extent. At sea levels 100 metres lower than today, much of the shallow northern part of the Gulf would have been dry land. The rivers that today flow into the Gulf, including the Sabarmati, the Mahi, the Narmada and the Tapi, would have continued flowing across what is now the seabed, cutting channels through land rather than emptying into open water. This is not speculation. It is established geology, supported by bathymetric surveys, sediment core analysis, and decades of research into post-glacial sea level change across the Indian Ocean region. The basic picture is not controversial among geologists or oceanographers. The Arabian Sea rose, the coastlines retreated. Land that was once exposed became submerged. The process was not instantaneous, and it was not always gradual in the way we might imagine. Sea level rise during the post-glacial period happened in pulses, with periods of relatively rapid rise interspersed with slower phases. Some researchers have identified episodes of particularly fast inundation, sometimes called meltwater pulses, during which sea levels could rise by several metres over the course of a few centuries. For communities living on low-lying coastal plains, those episodes would have been significant events. Not necessarily a single catastrophic flood in the way myths sometimes describe, but a sustained, irreversible encroachment of the sea over what had been livable land. By around 10,000 to 8,000 years ago, sea levels in the Arabian Sea were approaching something closer to their modern configuration, though the process continued more slowly after that. The Gulf of Kambat, as it exists today, took shape over this long period of inundation. The rivers that once crossed its floor became estuaries and then disappeared beneath the water. The coastal plains that had once supported whatever plant and animal life existed there were covered, layer by layer, by sediment and seawater. If people were living on those coastal plains, and there is no particular reason why they would not have been, then the evidence of their presence would now be underwater. Their settlements, their tools, their middens, whatever physical traces they left behind, would be somewhere on the floor of the Gulf of Kambat, buried under sediment, subject to the reworking effects of tidal currents, and lying at depths that make investigation genuinely difficult. This is not a remarkable or unusual idea. It is simply the application of well-understood geology to a specific region. What makes the Indian subcontinent particularly interesting in this context is the combination of its geography and its history. The western coast of India, including the Gujarat coast and the broader Arabian Sea shoreline, sits along a continental shelf that varies considerably in depth. In some areas, the shelf is relatively steep, and the transition to deeper water happens quickly. In others, the shelf is broad and shallow, meaning that even modest changes in sea level translate to large areas of land gained or lost. The Gulf of Kambat is one of the shallower parts of this system. Its average depth today is only around 20 to 30 metres in many areas, which means that even a relatively modest sea level drop of 40 or 50 metres would expose substantial portions of its floor. There are well-documented examples of exactly this kind of submerged landscape elsewhere in the world, and they are worth pausing on because they help calibrate what we are actually talking about. The most often cited example is Doggerland, the area of the North Sea between Britain and mainland Europe that was dry land during the last ice age. At its greatest extent, Doggerland was a substantial territory, probably supporting populations of Mesolithic hunter-gatherers who hunted across its plains and fished in its rivers. As sea levels rose after the last glacial maximum, Doggerland was gradually inundated, eventually disappearing beneath the North Sea entirely, probably by around 6,000 to 5,000 years ago. We know it existed because fishing trawlers have been pulling up mammoth bones, antlers, worked flint tools and other artefacts from the North Sea floor for over a century. Controlled surveys using sub-bottom profiling and careful sampling have revealed ancient river channels, lake beds, and coastlines preserved in the sediment. Doggerland is not a myth or a legend. It is a documented prehistoric landscape that happens to be underwater. A similar story applies to the floor of the Persian Gulf. During the last glacial maximum, the Persian Gulf was largely dry land, with the combined waters of the Tigris, Euphrates, Karun, and other rivers flowing through it toward the Gulf of Oman. The Gulf began to flood as sea levels rose, reaching roughly its modern extent by around 8,000 years ago. There is genuine archaeological interest in what might be preserved on the floor of the Persian Gulf, given that this region was inhabited during the period of inundation. Research in this area is ongoing and has produced some interesting results, though the Gulf presents its own logistical challenges. The Black Sea shelf is another example. The floor of the Black Sea contains evidence of a landscape that was once above water, and some researchers have proposed that the flooding of the Black Sea basin, which occurred when rising Mediterranean waters breached the Bosphorus threshold, may be connected to flood traditions in the cultures of the region. The details of that hypothesis are debated, but the basic geological event, the inundation of a formerly dry or partially dry basin, is not. The point of all these examples is that the idea of significant human habitation on land that is now underwater is not exotic or fringe. It is simply what happens when you combine the known patterns of post-glacial sea level rise with the obvious fact that people have been living near coastlines for as long as people have existed. Coastal environments are attractive for human settlement. They offer food from the sea, access to fresh water from rivers, and often relatively mild climates. These same factors that make coastlines attractive today made them attractive 10,000 years ago. The coastlines of 10,000 years ago are now, in many cases, underwater. Applied to the Gulf of Kambat, this means that the geological argument for the existence of submerged prehistoric sites in the region is genuinely strong. The land was there. People were probably using it. The sea rose and covered it. This sequence of events is not in dispute. What is in dispute is the specific nature of any sites that might be preserved on the floor of the Gulf, how old they are, how extensive they were, and whether the features identified in the 2001 sonar survey are actually the remains of human construction. It is worth being precise about what the geological argument does and does not establish. It establishes that the Gulf of Kambat was once, at least partially, dry land. It establishes that the inundation of that land occurred over a period of roughly 10,000 to 6,000 years ago, with the most significant flooding happening in the earlier part of that range. It establishes that any settlements on those coastal plains would now be underwater. It does not establish that the specific features seen in the sonar images are the remains of such settlements. It does not establish that the carbon date of approximately 9,500 years ago, obtained from a dredged wood fragment, accurately reflects the age of any structures, and it does not establish that the site is the legendary city of Dwarka. What it does do is make the general premise of the discovery plausible in a way that cannot simply be dismissed. If someone says there might be a submerged prehistoric site in the Gulf of Kambat, the geological record says yes, that is entirely possible. The sea was there. The land was there before the sea. People were living in this part of the world during the relevant period. The conditions for preservation of some kind of archaeological record exist, even if the conditions for investigating that record are extremely difficult. There is something quietly significant about this if you sit with it for a moment. The ancient texts that describe the submersion of Dwarka, the Mahabharata's account of the sea reclaiming the city, the Vishnu Purana's description of the ocean flooding in, these stories describe something that the geology of the region confirms was actually happening. Not necessarily to a city called Dwarka, not necessarily in the specific form the texts describe, but the general phenomenon of the sea advancing and covering inhabited coastal land is not a mythological invention. It is a geological fact about this part of the world. Communities living on the Gujarat coast and the shores of the Gulf of Kambat over the past 10,000 years would have experienced across generations the progressive loss of coastal land to the rising sea. It is not difficult to imagine that experience leaving a deep impression on the cultural memory of those communities, an impression that might eventually find expression in stories about cities swallowed by the ocean. The sea level history of the Arabian Sea also helps explain why the question of Dwarka, in its broader form, keeps generating serious interest despite the methodological problems with the 2002 claims. Even researchers who are skeptical of the specific Gulf of Kambat announcement tend to agree that the general question of submerged prehistoric settlement along India's western coast is a legitimate and important area of inquiry. The coastline has changed profoundly over the past 10,000 years. The people who lived on those coastlines left traces. Some of those traces are now underwater. Finding and studying them would tell us something genuinely significant about early human habitation in South Asia, about the development of coastal communities, and about the relationship between human settlement and environmental change. That last point, the relationship between human settlement and environmental change, feels particularly relevant in the present moment, though the narration here is not trying to force a contemporary moral onto an ancient story. But there is something worth noting in the fact that the communities who lived on the shores of the Gulf of Kambat 10,000 years ago were adapting to a world in which the sea was steadily advancing. The coastline they knew as children was not the coastline they knew as elders. The land their grandparents had farmed or fished might be underwater by the time they reached old age. That experience of a changing, encroaching sea is not entirely foreign to the present moment, even if the causes and timescales are different. The geological story, then, is one of the more solid pieces of the Dwarka puzzle, not because it proves anything specific about the sonar images or the dredged artifacts, but because it establishes the broad framework within which those specific claims should be evaluated. The sea rose. The land was covered. People were here. These things are known. What remains unknown is what exactly they left behind, and whether any of it survives in recoverable form on the floor of the Gulf. And that question, the question of what actually survives and what it looks like, brings us back to the archaeology itself, and to a distinction that tends to get lost in the popular coverage of this story. Because the Gulf of Kambat site, with its dramatic sonar images and its contested carbon date, is not the only underwater site associated with the search for Dwarka. There is a second site, closer to the modern city of Dwarka itself, that has been investigated in a more careful and systematic way, and that has produced findings which are, in some respects, more modest in their claims but considerably more defensible in their evidence. The distinction between these two sites matters quite a lot, and it is one that the headlines of 2002 largely failed to make. That distinction, the one between the Gulf of Kambat site and the underwater site near the modern city of Dwarka itself, is something worth settling carefully before moving on. Because in most popular coverage of this story, the two sites are treated as if they are the same discovery. They are not. They are separated by geography, by depth, by methodology, by the quality of the evidence, and by the nature of the claims being made. Conflating them does a disservice to both the science and the story. The site that generated the international headlines in 2002, the one with the sonar images and the carbon-dated wood fragment, sits in the Gulf of Kambat, roughly 40 kilometres off the coast of Surat. It is deep, inaccessible, and has never been properly excavated. The site we are turning to now sits in the waters directly off the coast of the modern city of Dwarka, in the northwestern corner of Gujarat, where the Gomti River meets the Arabian Sea. The water here is shallower, ranging from about 5 to 12 metres in the areas of primary interest. The tidal conditions are still difficult, but they are not the same extreme environment as the Gulf of Kambat. And crucially, divers have actually been down there. They have touched the stones, they have brought up artefacts. They have mapped what they found. The work at this site was led by S.R. Rao, the same marine archaeologist who had conducted the inshore excavations near the Dwarkadish temple beginning in the 1980s. Rao spent a significant portion of his later career focused on the offshore site, and the results of that work were eventually published in peer-reviewed form, which is a detail that matters quite a lot when evaluating any archaeological claim. Rao was not a fringe researcher. He was a senior figure at the Archaeological Survey of India, a man who had spent decades doing careful, methodical work. His conclusions about the offshore Dwarka site were specific, measured, and grounded in physical evidence that had been recovered under controlled conditions. What Rao's team found in the offshore waters near Dwarka included a number of features that are consistent with the remains of a built environment. There was what appeared to be a city wall, or at least a substantial masonry structure running along the seabed in a way that suggests deliberate construction, rather than natural formation. There was what Rao described as a bastion, a projecting fortified element of the kind typically found at the corners or entry points of ancient walled settlements. And there was a structure that Rao interpreted as a jetty, a landing platform extending into the water, consistent with the site having functioned as a harbour. These are not vague descriptions. The structures were physically examined by divers, measured and documented. Rao published drawings and photographs. The masonry was described in enough detail to allow comparison with other known ancient construction in the region. Among the physical artefacts recovered from the site, the most archaeologically significant were the stone anchors. These were triangular in shape, made from sandstone, and they had a distinctive hole at the apex for attaching a rope. This type of anchor, sometimes called a Harappan anchor, because it is associated with the maritime culture of the Indus Valley civilization and its successors, is known from other Bronze Age sites along the Indian coast and in the Persian Gulf. The fact that multiple examples were found at the offshore Dwarka site is meaningful, because stone anchors of this type are not random objects. They are markers of maritime activity. They indicate that ships were using this location, that it was a functioning harbour, and that it fits within a broader network of Bronze Age seafaring in the Arabian Sea. Alongside the anchors, Rao's team recovered pottery. The ceramic assemblage from the offshore site was compared with pottery from dated contexts on land, and the results placed it broadly within the range of 1500 to 3000 BCE. That is a wide range, and Rao was careful not to push it toward a more specific date without sufficient evidence. But it is consistent with the late Harappan and post-Harappan period, the era when the Indus Valley civilization was either at its height or in the process of gradual transformation and dispersal. A date in that range would make the offshore Dwarka site roughly contemporary with the later phases of the great cities at Mohenjo-daro and Harappa, which were themselves declining or already abandoned by around 1700 BCE. There was also a stone seal. Seals are particularly interesting finds in the context of Indus Valley archaeology because the Harappan civilization used seals extensively for trade, for identification, for administrative purposes. The seals found at Harappa and Mohenjo-daro are among the most studied objects from the ancient world, and their iconography, including the famous three-headed animal motif, has been the subject of enormous scholarly attention. This seal recovered from the inshore Dwarka excavations in the 1980s, which Rao had described earlier in his career, bore a similar three-headed animal motif, linking the site to the broader Harappan cultural sphere. The offshore finds added further material to this picture. Now, to be clear about what all of this does and does not establish. The offshore Dwarka site, as documented by Rao and his colleagues, presents evidence of a submerged settlement that appears to date to the Bronze Age, broadly consistent with the period between roughly 3000 and 1500 BCE. The physical evidence, the anchors, the pottery, the structural remains, and the seal is real and has been examined by qualified researchers. The site appears to have been a functioning harbour, possibly associated with a larger settlement. Some of its structures suggest planned construction rather than incidental accumulation. These are legitimate findings, and they represent a genuine contribution to our understanding of ancient maritime activity on India's western coast. What the offshore Dwarka site does not establish, at least not on the basis of the evidence published to date, is that it is the city of Krishna described in the Mahabharata and the Vishnu Purana. The mythological Dwarka is described as a city of extraordinary size and splendour, 12 yojanas in length, built on reclaimed land, surrounded by gardens and palaces and temples. The structures found by Rao's team are consistent with a real Bronze Age harbour settlement, which is genuinely significant, but they do not match the scale or the specific description of the legendary city. Rao himself believed the connection was real, and he argued for it with considerable conviction. But belief, even expert belief, is not the same as demonstrated evidence. The honest assessment is that the offshore Dwarka site shows us that there was a real ancient settlement in these waters, that it was a working harbour with connections to the broader Bronze Age world of the Arabian Sea, and that it is now submerged. Whether it was the specific city described in the ancient texts remains an open question. What makes the offshore site particularly valuable, beyond its own intrinsic interest, is precisely its modesty. It is not making claims that strain credulity. It is not asking us to accept that a 9,000-year-old civilization built geometric structures visible from sonar. It is saying something considerably more straightforward. Here is a Bronze Age harbour town, now underwater, recoverable through careful archaeological work. That kind of claim can be evaluated, tested, and refined. It fits within what we already know about the development of maritime trade in the Arabian Sea during the late 3rd and early 2nd millennium BCE. It connects to a well-documented historical reality. And that connection to a broader historical reality is worth pausing on for a moment, because it provides useful context for understanding what kind of site this might actually be. The Arabian Sea during the Bronze Age was not an empty expanse of water crossed only occasionally by brave sailors. It was a busy maritime corridor. The Indus Valley civilization, at its height between roughly 2600 and 1900 BCE, maintained extensive trade networks that extended westward to Mesopotamia, southward along the Indian coast, and eastward into the interior of the subcontinent. Goods moved by sea. Ports were essential. The Gulf of Kambat and the coast of Gujarat were part of this world, and there is good reason to think that multiple settlements along this coastline were functioning as nodes in a larger network of Bronze Age maritime trade. Lothal, which sits inland from the Gulf of Kambat in Gujarat, is one of the best documented examples of a Harappan port city. Excavated by Rao himself in the 1950s and 1960s, Lothal contained what is widely considered the oldest known dock in the world, a brick-lined basin connected to the river by a sluice gate. The The presence of Lothal tells us that the Harappan civilization was building purpose-designed maritime infrastructure in this region. It tells us that the people of the Indus Valley were sophisticated sailors and traders, capable of planning and constructing facilities specifically designed for the loading and unloading of ships. Given that, the idea that similar settlements existed along the coast near modern Dwarka is not remarkable at all. It would be more surprising if they did not. The offshore Dwarka site in this reading is not necessarily the legendary city of Krishna. It may be something in some ways more interesting. A real node in the Harappan maritime network, a working port that served the trade routes of the Bronze Age Arabian Sea, now sitting quietly under 10 metres of water, having been progressively submerged as the sea level rose over the millennia following the end of the last glacial period. That story, the story of a real Bronze Age harbour town lost to the rising sea, is already remarkable without any need for mythological embellishment. The confusion between this site and the Gulf of Kambat site is not entirely accidental. Both sites are associated with the name Dwarka, both involve claims about submerged ancient settlements, and both emerged into public awareness during roughly the same period. The 2002 announcement about the Gulf of Kambat discovery was so large and so dramatic that it effectively swallowed the more careful, more modest and more scientifically grounded work that Rao had been doing near the modern city of Dwarka for years. When journalists and documentary makers went looking for the underwater city of Dwarka, they naturally gravitated toward the more dramatic story, the sonar images, the 9,000-year-old date, the claim of a lost civilization. The nuanced distinction between that claim and Rao's published findings near the actual city of Dwarka was not the kind of thing that made for exciting headlines. This conflation has had real consequences for how the topic is understood and discussed. People who have heard the Dwarka story typically have a version of it in their heads that combines elements from both sites. The sonar images from the Gulf of Kambat, the Bronze Age artifacts from the offshore Dwarka excavations, the carbon date from the dredged wood fragment, and the mythological narrative from the Mahabharata into a single composite picture. That composite picture is not an accurate representation of any one of those things. It is a kind of averaging of different claims that produces something that resembles none of them precisely. Separating the two sites does not diminish the story. If anything, it makes it more interesting, because it reveals that there are actually two distinct and genuinely significant questions here. The first question is whether the Gulf of Kambat sonar images represent the remains of a prehistoric settlement, and whether the dredged artifacts are genuinely associated with any structures on the seabed. That question remains unresolved, and resolving it would require a level of archaeological investigation that has not yet been carried out. The second question is what exactly the offshore Dwarka site represents, how large it is, how old the oldest parts of it are, and what its relationship might be to the broader network of Harappan maritime activity in the Arabian Sea. That question is more tractable because the site is shallower, more accessible, and has already yielded real physical evidence that can be examined and built upon. Both questions are worth asking. Both deserve serious scientific attention, and both have been somewhat obscured by the noise generated around the 2002 announcement, which was large enough and dramatic enough to define the public understanding of Dwarka for years afterward, regardless of what the actual evidence did or did not support. There is one more thing worth noting about Rao's offshore work, and it has to do with what was not found as much as what was. The structures identified near Dwarka, the wall, the bastion, the jetty, sit at depths of roughly 5 to 12 metres. Given what we know about sea level history in the Arabian Sea, those depths are consistent with submersion occurring somewhere in the range of roughly 3,000 to 5,000 years ago, broadly consistent with the Bronze Age dating suggested by the artifacts. This is not a 9,000-year-old site. It is not a lost civilization predating the Indus Valley. It is, in all probability, a submerged extension of the same coastal Bronze Age world that produced Lothal and the other Harappan port settlements. That makes it historically significant in a way that does not require extraordinary claims. And yet, For all the care and precision of Rao's published work, there is still much about the offshore Dwarka site that remains unknown. The extent of the submerged area has not been fully mapped. The relationship between the offshore structures and the inshore remains near the Dwarkadish temple has not been fully worked out. The question of whether the settlement extended further offshore into deeper water has not been answered. These are not unanswerable questions. They are questions that a sustained, well-funded, methodologically rigorous investigation could address. But that investigation has not yet happened, at least not at the scale the site deserves. Which brings us naturally to the people who have actually done the work of going down there, to the divers and researchers who have spent time in these waters, running their hands along ancient stone in conditions that most of us would find deeply uncomfortable. Because understanding what the investigation of this site actually involves, physically, practically, in terms of what the human body encounters when it enters these waters, tells us something important about why the questions have remained open for so long, and why settling them is genuinely difficult even when the will to do so exists. There is a particular kind of silence that exists underwater, not the silence of a quiet room or a still night, but something denser, more complete, more physical. Sound moves differently in water than it does in air. It travels faster, but it also arrives strangely, without direction, without the cues the human brain normally uses to locate a source. Down there, sound seems to come from everywhere and nowhere at once. And when visibility is low, when the water around you is thick with suspended sediment, and you can barely see your own hand in front of your face, that disorientation of sound combines with the disorientation of sight in a way that is genuinely unsettling, even for experienced divers. This is the environment that the archaeologists and researchers working near Dwarka and in the Gulf of Kambat have had to contend with, not as an abstract logistical problem, but as a daily physical reality. The Gulf of Kambat is, by almost any measure, one of the most challenging bodies of water in the world for underwater work. The tidal range in the Gulf is enormous. At its northern end, near the head of the Gulf, tidal fluctuations can reach 10 to 12 meters, among the highest recorded anywhere on the planet. That kind of tidal movement generates currents of extraordinary strength. During a tidal cycle, water rushes in and out of the Gulf with enough force to carry enormous quantities of sediment, stirring the seabed, keeping particles in suspension, and reducing underwater visibility to near zero for much of the day. Divers working in those conditions are not swimming through clear water with good sight lines and comfortable time to examine what they find. They are working in a kind of moving brown soup, feeling their way along surfaces they cannot see, managing their buoyancy against currents that can shift without warning, and watching their bottom time with extreme care because the window of workable conditions is narrow. That window is called slack water. It is the brief period between tidal phases when the current slows before reversing direction. In the Gulf of Kambat, the slack water window can be as short as 20 minutes. On a good day, perhaps 40. That is the entire usable working period in a given tidal cycle. A diver descends, reaches the working depth, and has perhaps half an hour before the current begins to build again, and conditions become dangerous. In that half hour, they must orient themselves, locate the area they intend to examine, conduct whatever work is possible, document what they find, and begin their ascent in time to decompress safely and surface before the current returns. It is not a generous allowance of time for any kind of careful scientific work, let alone the meticulous, slow, methodical work that underwater archaeology requires. The conditions near the modern city of Dwarka, where S.R. Rao's team conducted their offshore work, are somewhat better, but still far from easy. The tidal range is less extreme, and the water, while still carrying significant sediment, can occasionally offer a visibility of a metre or two, sometimes a little more on a calm day with favourable conditions. But the operative word is occasionally. The Arabian Sea off the Gujarat coast is not a calm, tropical diving destination. It has its own currents, its own seasonal variability, its own periods of rough weather. The monsoon season, which typically runs from June through September, makes any kind of offshore work essentially impossible. The sea state during monsoon can be severe, with heavy swells and strong winds that preclude boat operations, let alone diving. That leaves a working season of perhaps 6 to 7 months in a year, and within that season, individual dive conditions can vary enormously from day to day. The ASI divers who worked with Rao near the Dwarka temple in the earlier inshore excavations described conditions that were, by any normal standard, extremely demanding. The temple itself sits close to the sea, and the submerged structures nearby lie in water that is shallow enough to be affected by wave action, which stirs up sediment and further reduces visibility. Some of the divers working those inshore sites reported visibility of less than half a metre on many days. In practical terms, that means you are working essentially by touch. You descend, you locate a structure by feel, you run your hands along its surface to understand its shape, its texture, its extent. You cannot photograph it usefully because there is nothing for a camera to see. You cannot draw it from observation because you cannot observe it. You build your understanding of what you're touching through your fingertips, and you record what you can through whatever instruments and measurement tools you have carried down with you. There is something quietly remarkable about that image. A person 10 metres underwater, in near zero visibility, running their hands along a stone wall that may have been built 3,000 years ago by people who lived in a coastal city that is now beneath the sea. It is not the dramatic, photogenic version of underwater archaeology that appears in documentaries, with crystal clear water and divers gliding past perfectly preserved amphorae. It is slow, physical, uncomfortable, and demanding, and it requires a particular kind of patience and discipline that goes beyond the technical skills of diving. You have to be willing to work in conditions where your senses are largely unavailable to you, where the environment actively resists your presence, and where the rewards of any given dive may amount to a few measurements, a handful of observations, and the knowledge that you covered a small area of seabed that no one had properly examined before. The equipment used in these investigations tells its own story about the difficulty of the work. Side-scan sonar, which was the primary tool used in the Gulf of Cambut survey, works by emitting sound pulses from a towfish dragged behind a vessel and recording the echoes that return from the seabed. It can produce remarkably detailed images of bottom topography over large areas relatively quickly, and it does not require anyone to enter the water at all. But what it produces is an acoustic image, not a visual one, and interpreting that image requires significant expertise and considerable caution. Features that look geometric in a sonar image are not necessarily artificial. Natural rock formations, fracture patterns, erosion channels, and sediment deposition features can all produce regular-looking shapes in acoustic data. The sonar image tells you something is there and gives you a rough sense of its shape and scale. It does not tell you what it is made of, how old it is, whether it was worked by human hands, or whether the geometry is the result of human intention or natural process. For those answers, you have to go down and look. And in the Gulf of Cambut, going down and looking is, as we have established, extremely difficult. Sub-bottom profilers are another tool used in these surveys. They work on a similar acoustic principle, but are designed to penetrate beneath the seabed surface and reveal what lies below. The layering of sediments, buried features, potential structures hidden under accumulations of silt and sand. In a site like the Gulf of Cambut, where the seabed is covered by layers of sediment deposited over thousands of years of tidal activity, sub-bottom profiling can suggest the presence of buried features that would otherwise be invisible. But again, the data requires careful interpretation, and the resolution is limited. Sub-bottom profilers can tell you that something is there. They cannot tell you with confidence what it is. Underwater cameras in conditions of very low visibility are of limited use. A camera can only record what light can illuminate and what the lens can see through. In water-carrying heavy sediment, even powerful artificial lights illuminate only a small murky sphere around the camera housing. Photographs taken in those conditions often show little more than a grey-brown haze with vague shapes at the edges. Video can be more useful, because motion sometimes helps the eye distinguish structure from background. But the fundamental limitation of visibility cannot be overcome by better camera technology alone. You can have the finest underwater camera system in the world, and if the water around you is opaque with suspended particles, the images you produce will still be largely uninformative. This is part of why the investigations of both the Dwarka offshore site and the Gulf of Kambat site have produced so much ambiguity. The physical conditions of the sites are not incidental to the scientific uncertainty. They are a direct cause of it. When you cannot see what you're examining, when your working time is measured in minutes, when the tools available for remote sensing produce data that requires interpretive judgment rather than clear answers, the result is inevitably a body of evidence that is suggestive rather than conclusive. People who look at that evidence and feel frustrated by its inconclusiveness are sometimes inclined to blame the researchers for not working harder or not being thorough enough. But the researchers who have worked these sites have generally worked under conditions that would test anyone's thoroughness. The environment itself is the limiting factor. There is a human cost to this work that does not always get acknowledged in the discussion of evidence and dating and sonar images. The divers who worked with RAU over the years, many of them SI staff rather than professional research divers, made dozens and eventually hundreds of dives in difficult conditions to build up the picture of the offshore Dwarka site that now exists in the published literature. Each of those dives involved the physical demands of entering cold or warm water in strong conditions, managing equipment, navigating to a target site without visual references, conducting careful work in a narrow time window, and returning to the surface without incident. Diving is not inherently dangerous if done correctly, but it is a demanding activity that requires constant attention, and doing it repeatedly in challenging conditions over an extended field season takes a real physical and mental toll. Some of the researchers involved in the Gulf of Kambat investigation have described the experience of working in those waters in terms that convey a kind of visceral frustration. The site, as seen in the sonar images, is large and apparently complex. The features that appear in the acoustic data suggest something worth examining very carefully. But every time a diver enters the water, the conditions conspire to prevent the kind of detailed examination that would be needed to say anything definitive. The current is too strong, or the visibility is too low, or the slack water window closes before the work is done, or the sediment disturbed by the diver's own movements clouds the water further and reduces visibility to nothing. It is a site that seems to resist investigation, not because of anything mysterious, but simply because of the physics of water and sediment and tidal flow. What the researchers have managed to establish, through this difficult and painstaking work, is still meaningful. Near the offshore Dwarka site, the physical presence of the structures RAU identified has been confirmed by multiple dives across multiple seasons. The stone anchors recovered from the site are a well-understood artifact type, with parallels from other Bronze Age maritime sites in the region. The pottery recovered is consistent with the dating suggested by the anchor typology. The structural remains, the wall, the bastion, the jetty, are coherent with each other in terms of construction style and apparent age. This is not a case of a single ambiguous find. It is a body of evidence that, taken together, makes a reasonable case for the presence of a real submerged settlement of Bronze Age date. The case is not airtight, because the conditions of the site have prevented the kind of systematic excavation that would make it airtight. But it is a genuine body of evidence, assembled under difficult conditions by researchers who work carefully within the constraints they faced. What has not been established, and what the physical conditions of the sites have so far made impossible to establish, is the full extent of either site, the precise stratigraphy of the deposits, the relationship between surface and buried features, and the detailed spatial organisation of whatever structures exist. These are not minor gaps. In archaeology, knowing the extent of a site, understanding its stratigraphy, and mapping its spatial organisation are foundational to interpreting what the site represents. Without that information, even a well-documented collection of artifacts and structures tells only a partial story. You know something was there. You know roughly when. But you cannot fully understand what it was, how it functioned, how large it was, or how it fits into the broader picture of human activity in the region. This is the situation that the Dwarka offshore site finds itself in. Enough has been found to make the site genuinely significant. Not enough has been found to answer the most important questions about it. And the physical conditions of the site, the visibility, the tidal windows, the sediment, the currents, mean that closing those gaps requires not just willingness and effort, but sustained resources, careful planning, and probably the application of technologies that were not available to the earlier investigators, which is, when you think about it, both a limitation and an opportunity. The story of what lies beneath the water near Dwarka is not finished. It is, in a real sense, still being written, one difficult dive at a time, one careful sonar pass at a time, one painstakingly recovered artifact at a time. And Dwarka, as it turns out, is not the only place along this coastline where the sea appears to be holding something back. The more you look at the history of India's western and southern coasts, the more you begin to notice a pattern, a recurring suggestion that the land now beneath the water was once inhabited, once built upon, once part of a living coastal world that has since been swallowed by the rising sea. The Dwarka sites are perhaps the most discussed, but they are not alone. Along the Indian coast, from Gujarat in the north to Tamil Nadu in the south, there are other sites, other claims, other pieces of evidence that point toward the same broad question. How much of early Indian coastal civilization is now underwater, and what would we find if we could properly look? That pattern, once you start seeing it, is difficult to ignore. India's coastline is long. It stretches for roughly 7,500 kilometres if you follow it from the Gujarat coast in the northwest, all the way around the southern tip of the subcontinent and back up to the Bay of Bengal in the east. And along much of that length, the sea level history is the same as it is near Dwarka. 10,000 years ago, the coastline was significantly further out. The shallow continental shelf that now lies beneath the Arabian Sea and the Bay of Bengal was, at the end of the last ice age, dry land. River mouths that now empty into open water once emptied into coastal plains. Beaches that now sit under 20 or 30 metres of seawater were once places where people could have walked, fished, built shelters, lit fires. The sea came in gradually, over centuries, and it covered all of that. The question of what it covered and how much of it was inhabited is one that archaeologists and geologists are still working out. Pumpuar is one of the places where that question becomes very concrete. It sits on the Tamil Nadu coast near the mouth of the Kaveri River, roughly 300 kilometres south of Chennai. In ancient Tamil literature, particularly in the Sangam texts, a city called Kavaripattinam is described as a great port, wealthy, cosmopolitan, a place where merchants from distant lands came and went, where the streets were wide, where music could be heard from the upper stories of fine houses. The texts describe it as eventually being swallowed by the sea. The name Pumpuar is associated with this city, and for a long time the story of its submersion was treated as literary embellishment, the kind of dramatic ending that storytellers add to give a place a sense of weight and tragedy. Then, in the 1990s, the Archaeological Survey of India conducted marine surveys off the Pumpuar coast. What they found was interesting. At a depth of around 5 to 6 metres, relatively close to shore, there were structural remains, walls, foundations, features that appeared to be man-made. This was not entirely surprising. Coastal erosion and modest sea level changes could account for structures at that depth being submerged within a historically documented period. The Tamil texts describe Kavaripattinam as existing during the early centuries of the Common Era, so structures at 5 or 6 metres could plausibly date to that period and be consistent with known sea level changes. But then there is a second set of features at Pumpuar, and this is where the story becomes more complicated. At a depth of around 23 metres, significantly further offshore, sonar surveys and some diver observations have identified what appears to be a large, roughly circular or horseshoe-shaped structure. It is large, perhaps 40 metres across. Its shape and regularity have led some researchers to suggest it is man-made. At 23 metres depth on this part of the Indian coast, the sea level history suggests that this area would have been dry land approximately 11,000 years ago, during the period immediately following the last glacial maximum. If the structure is man-made and dates to that period, it would be extraordinarily significant, pushing back the evidence for complex construction in South Asia by thousands of years beyond anything currently accepted. Graham Hancock, the author and researcher who has written extensively about the possibility of advanced prehistoric civilizations, has pointed to the Pumpua offshore structure as one of his key pieces of evidence. Hancock is not an archaeologist, and his broader claims about lost prehistoric civilizations are not accepted by mainstream science. But the structure at Pumpua is real in the sense that the sonar data exists and some divers have visited the site. What it actually is, a natural geological formation, a much more recent structure at a depth that requires a different explanation, or something genuinely ancient, has not been definitively determined. The site has not received the kind of sustained, systematic investigation that would settle the question, and so it sits in an ambiguous position, interesting, potentially significant, but not yet understood. Mahabalipuram is a different kind of case, and in some ways a more instructive one, because it involves a moment when the sea briefly gave something back. Mahabalipuram, also known as Mamallapuram, is a town on the Tamil Nadu coast about 60 kilometres south of Chennai. It is famous for its rock-cut temples and carved monuments from the Pallava dynasty, dating to roughly the 7th and 8th centuries of the Common Era. Local tradition had long maintained that there were more temples offshore, swallowed by the sea, and that the structures visible on land were only a remnant of a much larger complex. This was, again, treated largely as legend. Then, on the morning of December 26, 2004, the Indian Ocean tsunami struck. The wave that hit the Tamil Nadu coast was devastating in human terms. But in the minutes before the wave arrived, the sea did something that tsunami witnesses sometimes describe. It pulled back. The water receded dramatically, exposing the shallow seabed for some distance offshore. And in that brief window, people standing on the shore at Mahabalipuram saw things on the exposed seabed that were not normally visible. Stone walls, carved blocks, what appeared to be structural remains arranged in ways that suggested they had once been buildings. When the water returned, those features disappeared again beneath the surface. But the observations had been made by multiple witnesses, and they were taken seriously. In the weeks and months following the tsunami, the Archaeological Survey of India conducted underwater surveys near Mahabalipuram. They found structural remains at depth of up to about 6 metres, including what appeared to be a large sculpted lion, granite blocks with decorative carving, and wall sections consistent with Pallava period construction. These were not ambiguous sonar images. Divers physically examined and photographed carved stone. The ASI concluded that there was indeed a submerged temple complex off the Mahabalipuram coast, consistent with the local tradition of a city lost to the sea. The Mahabalipuram discovery is important for a few reasons. It confirmed that local traditions about submerged structures can be accurate. It demonstrated that the sea has indeed swallowed built structures along the Indian coast within historical time. And it showed that underwater investigation, when conditions allow and commitment is sustained, can produce clear and documented results. The Mahabalipuram structures are not as old as the claims made about the Gulf of Kambat site, and the water is shallower and clearer than the murk of the Gulf. But as a proof of concept, the discovery matters. It establishes that the pattern of submerged coastal sites along India's shores is not purely speculative. Further north, along the Gujarat coast not far from the modern city of Dwarka, there are additional reports of submerged structures in relatively shallow water. Local fishermen in the region have long known about stone features on the seabed in certain areas, features they navigate around or use as landmarks. Some of these have been examined by divers and found to include worked stone and what appear to be structural arrangements. None of these sites have been fully excavated or comprehensively documented, but their existence adds to the broader picture of a coastline that has changed significantly, and that was, in various places, inhabited by people who built things that the sea has since covered. The broader geological context for all of this is worth sitting with for a moment. The Indian subcontinent sits on a tectonic plate that has been relatively stable for a long time in geological terms, but the coasts have not been static. The sea level changes driven by the end of the last ice age were global, and they affected India's coastline just as they affected coastlines everywhere else. The continental shelf along India's western coast is wide in places, meaning that a drop in sea level of even a few tens of meters exposes a significant area of land. Conversely, when sea levels rose at the end of the ice age, large areas of what had been coastal plain were progressively inundated. Rivers that had flowed across those plains were shortened, their lower reaches becoming estuaries and then open water. The land that had been at the river mouths, often the most fertile and desirable land for early settlements, went underwater. This is not a uniquely Indian story. The same process happened everywhere. In the North Sea, a landmass called Doggerland connected Britain to continental Europe until roughly 6,500 to 8,000 years ago. It was inhabited by Mesolithic people, and artifacts including tools, animal bones, and human remains have been dredged from the North Sea floor over many decades. In the Persian Gulf, which was largely dry during the last glacial maximum, there are suggestions of submerged settlements on what was once the Gulf floor. Around the coast of Australia, researchers have identified areas of submerged continental shelf that would have been dry land during the period of Aboriginal settlement, and oral traditions from some Aboriginal communities appear to describe features of the landscape that are now underwater. The submersion of coastal lands at the end of the Ice Age was a global event that affected every coastal-dwelling human population on Earth. What makes the Indian situation particularly interesting and particularly complex is the combination of factors that converge there. You have a coastline that changed significantly. You have ancient texts that describe the submersion of specific cities in specific ways. You have a living tradition of pilgrimage and sacred geography centered on coastal sites. You have a long history of maritime activity, trade and coastal settlement stretching back thousands of years. And you have now a growing body of underwater survey data that suggests the submerged coastal shelf is not empty. All of these things are true simultaneously, and they interact with each other in ways that make the question of what is down there both more interesting and more difficult to answer cleanly. The difficulty is partly scientific and partly institutional. Underwater archaeology anywhere in the world is expensive, technically demanding, and slow. Underwater archaeology in India faces additional challenges: limited funding for marine research, a relatively small community of trained underwater archaeologists, complex bureaucratic processes for conducting marine surveys, and the physical conditions of the sites themselves, which in places like the Gulf of Kambat are among the most challenging in the world. The sites that have been investigated have mostly been investigated on limited budgets, with limited equipment by small teams working under difficult conditions. The results, given those constraints, are actually rather remarkable. But the constraints also mean that the investigations have been incomplete, and incomplete investigations leave the most important questions unanswered. There is also a cultural and political dimension that is worth acknowledging, because it shapes how the evidence is received and discussed. In India, the question of Dwarka's submersion is not simply an archaeological question. It is connected to religious identity, to national history, to the status of the Mahabharata and other ancient texts as historical sources. When a government minister announces a discovery of a 9,000-year-old city, before the evidence has been peer-reviewed, that is not purely a scientific communication failure. It reflects the weight that the question carries in a cultural and political context. The desire for the discovery to be real, to confirm the historicity of the ancient texts, to establish the antiquity of Indian civilization, is a powerful force, and that force can distort the way evidence is presented, interpreted, and received. This does not mean the evidence is fabricated or that the sites are not real. It means that the question of what the sites actually represent needs to be approached with particular care, precisely because so much more than archaeology is riding on the answer. What the accumulation of evidence from Pumpahar, Mahabalipuram, the inshore Dwarka sites, the Gulf of Kambat survey, and the other reported sites along the Indian coast does establish, even if it does not resolve the specific claims about each site, is that the question itself is legitimate. The Indian coast has changed. People lived on those coasts. Some of what they built is now underwater. How much, exactly where, and how old are questions that have not yet been fully answered, and the answers, when they come, will almost certainly be significant. The pattern is real, even if the details remain to be worked out, and that pattern, that recurring suggestion of a submerged coastal world stretching from Gujarat to Tamil Nadu and beyond, is what gives the Dwarka question its larger significance. Dwarka is the most famous of these sites, the most discussed, the most loaded with mythological and religious meaning. But it is not an isolated anomaly. It sits within a broader context of coastal submersion and potential submerged settlement that runs the full length of the Indian coastline. Understanding Dwarka properly means understanding that context, and understanding that context means grappling with the possibility that the sea has swallowed not just one city, not just one settlement, but a whole dimension of early Indian coastal life that we have barely begun to examine. Which brings the question, inevitably, to what it would actually take to examine it properly, to move from suggestive sonar images and incomplete dredge samples, and frustratingly brief diver observations to the kind of systematic, documented, scientifically defensible investigation that could finally begin to answer what is down there and what it means. So what would it actually take? That is the question that sits at the centre of all of this, and it is worth sitting with for a moment before trying to answer it. Because the gap between what we currently know about the Dwarka sites and what we would need to know in order to say something definitive is not a small gap. It is not the kind of gap you close with one well-funded expedition or a single good diving season. It is a methodological gap, a logistical gap, and in some ways an institutional gap. And understanding what it would take to close it is itself a way of understanding why the question has remained open for as long as it has. Start with the most basic problem, which is also the most consequential one. The way material was recovered from the Gulf of Kambat site in the early 2000s was, by the standards of modern archaeology, not recoverable as evidence. Dredging, which is the mechanical scooping of sediment from the seabed, is a technique that has its uses in engineering and in preliminary survey work. But it is not excavation. It does not preserve the relationship between objects and the layers of sediment they were found in. That relationship, what archaeologists call stratigraphy, is not incidental to the evidence. It is the evidence. When you find a piece of pottery, the question is not just what the pottery is. The question is where exactly it was, how deep, what was above it, what was below it, what was found alongside it. Those relationships tell you when the object was deposited, whether it was moved by water or left in place, whether it belongs to the same occupation layer as other objects found nearby. When you dredge, you destroy all of that. You pull material out of context, mix it together, and then try to make sense of what you have. It is a little like emptying several bookshelves into a single bag and then trying to reconstruct the order that the books were shelved in. You still have the books, but the information about their arrangement is gone. This is why the carbon dating of the wood fragment recovered from the Gulf of Kambat site, while genuinely striking, cannot be used as direct evidence of the age of any structure at that site. The wood dated to approximately 9,500 years ago. That date may be accurate for the wood itself. But without stratigraphic context, there is no way to know whether that wood was associated with any structure, whether it was deposited naturally by river currents, whether it came from the same depth as the sonar anomalies, or whether it arrived at the site independently and at a different time. The date is real. The connection to the structures is not established. What would establish that connection is controlled excavation. Underwater controlled excavation is technically demanding, slow and expensive, but it is not impossible. Marine archaeologists have conducted it successfully at sites around the world, including in conditions that are challenging by most standards. The methodology is well developed. You establish a grid over the site, dividing the seabed into measured squares. You excavate each square systematically, removing sediment carefully and documenting every object in its exact position before it is moved. You record depth, orientation, and the relationship between objects. You photograph and video everything. You take sediment samples from different layers for dating and environmental analysis. You keep meticulous written records. When an artifact is removed, it is bagged, labelled with its precise location, and treated as a piece of evidence in a legal sense, because in archaeology, provenance is everything. On land, this process is painstaking but manageable. Underwater, everything becomes more difficult. Visibility is the first problem. In the Gulf of Kambat, visibility can be less than half a metre, sometimes less than that. Working in near-zero visibility while trying to document the precise position of small objects is genuinely difficult. Divers have to work largely by touch, feeling along surfaces, which limits both speed and accuracy. You cannot photograph what you cannot see. You cannot measure what you cannot find by eye. Some of this can be compensated for with specialised lighting, with underwater video systems that enhance contrast, with careful, slow work. But the visibility conditions in the Gulf of Kambat represent a real constraint that cannot be fully engineered away. The tidal window is the second problem. As described earlier, the Gulf of Kambat experiences extreme tidal flows, and the window of slack water during which diving is safely possible may be only 20 to 40 minutes per tidal cycle. If you're lucky, you might get 2 usable windows per day. That is perhaps an hour of actual working time at the bottom, spread across 2 separate dives. In that time, a diver working in low visibility on a controlled excavation grid might clear and document a few square meters of seabed. Multiply that by weeks or months, and you begin to understand the scale of the logistical challenge. A site that might take a land archaeologist a single field season to excavate could take an underwater team years to cover the same area, assuming consistent access and good conditions, neither of which is guaranteed in the Gulf of Kambat. This is where remotely operated vehicles become relevant. ROVs, as they are commonly called, are underwater robots that can be operated from a surface vessel without requiring human divers to be in the water. They can carry cameras, lights, sonar systems, and in more sophisticated versions, robotic arms capable of manipulating objects. The advantages are significant. An ROV does not need to breathe. It is not limited by the tidal window in the same way a diver is, though strong currents still affect its manoeuvrability. It can carry high-resolution cameras and record continuously. It can hover over a feature for as long as its power supply allows, examining it from multiple angles. In clear water, a good ROV can produce detailed photographic and video documentation of underwater features that would be very difficult to achieve with divers alone. The limitation is that visibility. In the Gulf of Kambat, even the best camera system will struggle with water that carries a heavy sediment load. Lights that would illuminate a feature clearly in the Mediterranean or in the clear waters of the Caribbean produce only a diffuse glow in turbid water. Some researchers have proposed using acoustic imaging systems, which use sound rather than light to build images, and these can function in zero visibility conditions. Sub-bottom profilers, which send acoustic signals through the seabed, and record the reflections from different layers can reveal buried features without removing any sediment at all. These tools have been used in preliminary surveys at various Indian sites, and they have produced suggestive results. But suggestive results from acoustic imaging still need to be followed up with direct physical investigation to confirm what the signals actually represent. There is also the question of what legal and institutional framework governs underwater archaeological sites in India. The UNESCO Convention on the Protection of the Underwater Cultural Heritage, which was adopted in 2001, establishes international standards for the investigation and protection of underwater heritage sites. It requires that underwater cultural heritage be protected in place as a first priority, that any investigation be conducted according to scientific standards that preserve the archaeological record, and that dredging and other forms of commercial or non-scientific recovery be prohibited. India has not formally ratified this convention, though it has participated in discussions around it. The domestic legal framework for underwater archaeology in India has historically been less developed than the framework for land archaeology, which falls under the Archaeological Survey of India and is governed by the Ancient Monuments and Archaeological Sites and Remains Act. The application of that act to underwater sites has been somewhat unclear, and the institutional capacity for underwater archaeological work within the ASI has been limited. This matters because sustained scientific investigation of the Dwarka and Gulf of Kambat sites would require not just funding and equipment, but a clear legal mandate, institutional responsibility, and protection of the sites from disturbance. Without legal protection, a site of potential archaeological significance can be damaged by fishing activity, by shipping, by industrial development, by well-meaning but uncontrolled amateur diving, or by the kind of non-scientific recovery that destroys context. The Gulf of Kambat is an active commercial and industrial waterway. The pressures on the seabed there are not trivial. Funding is the other obvious constraint, and it is worth being direct about it. Marine archaeology is expensive. A properly equipped research vessel with a sonar, ROV, and laboratory facilities needed for serious underwater investigation costs significant money to operate per day. A multi-season investigation of a large site could run into costs that are substantial by the standards of academic archaeology. In India, as in most countries, archaeological research budgets are limited, and underwater archaeology has historically received a smaller share of those budgets than land archaeology. There have been calls from researchers within India for greater investment in marine archaeological infrastructure, including a dedicated research vessel, expanded training for underwater archaeologists, and a more robust institutional framework. Some progress has been made. The National Institute of Ocean Technology has continued to conduct surveys. The ASI has maintained some capacity for underwater work, but the scale of the investment has not matched the scale of the questions. What a genuinely adequate investigation would look like if the resources and institutional will were available is something like this. A multi-year research program coordinated between the ASI NIOT and ideally international partners with relevant expertise, using a combination of high-resolution multi-beam sonar mapping, sub-bottom profiling, ROV survey with acoustic imaging, and targeted controlled excavation at carefully selected locations within the site. The program would begin with comprehensive mapping to establish the full extent and character of the anomalies. It would then use ROV survey to examine the most promising features in detail, building a photographic and acoustic record. Only then would excavation begin at locations chosen on the basis of the survey data, using the most rigorous methodology that conditions allow. Artifacts would be recovered with full stratigraphic documentation. Sediment samples would be taken from multiple layers for radiocarbon dating, for pollen analysis, for environmental reconstruction. The results would be published in peer-reviewed scientific journals and made available for independent review. This is not an impossible program. It is the kind of investigation that has been conducted at other challenging underwater sites around the world. The Mary Rose, the Tudor warship raised from the Solent in the 1980s, was the subject of a decade-long underwater excavation before its recovery. The Bronze Age shipwrecks at Uluburun off the coast of Turkey were excavated over 11 field seasons beginning in 1984, with divers making more than 22,000 dives to document and recover the cargo. The submerged prehistoric landscapes of the North Sea have been studied through a combination of sediment coring, dredge sampling, and careful analysis of material brought up by commercial fishing, building a picture of Doggerland over decades of patient work. None of these investigations were quick. All of them were expensive. All of them required sustained institutional commitment. And all of them produced results that fundamentally changed our understanding of the past. The Dwarka sites are not obviously more difficult than some of these. The Gulf of Kambat visibility problem is genuinely severe, but it is not unique. The tidal conditions are challenging but manageable with proper planning. The depth of the sites, 30 to 40 metres in the Gulf of Kambat, is within the range of standard scientific diving and well within the operational range of most research-grade ROVs. The obstacles are real, but they are not insurmountable. What has been missing is not capability. It is commitment. There is something a little frustrating about that if you think about it. The question of whether there is a submerged human settlement in the Gulf of Kambat, and if so how old it is and what it represents, is a genuinely significant scientific question. It has implications for our understanding of the timeline of complex human settlement in South Asia. It has implications for how we interpret ancient texts that describe coastal cities and their submersion. It has implications for the broader global picture of how rising sea levels at the end of the last ice age affected human populations worldwide. These are not trivial questions, and the site has been known, in one form or another, for more than 2 decades. The sonar images from the 2001 survey are now old enough to have graduated from university, and yet the definitive investigation has not happened. Part of the reason is the politicisation of the discovery. When the Gulf of Kambat findings were announced in 2002 as confirmation of a 9,000-year-old city, before the evidence was properly evaluated, it created a polarised response. Skeptics dismissed the whole thing. Enthusiasts overclaimed. The scientific middle ground, where patient, rigorous investigation might have proceeded, became harder to occupy. Researchers who expressed caution were sometimes accused of cultural bias or of trying to diminish Indian history. Researchers who expressed enthusiasm were sometimes accused of allowing religious and nationalist sentiment to override scientific judgment. Neither characterization was entirely fair, but both reflected real tensions. And those tensions made it harder to build the kind of broad scientific consensus that sustained, well-funded investigation requires. The sites themselves are not going anywhere. The sea is not giving up its secrets on its own schedule just because we are impatient. The sonar anomalies in the Gulf of Kambat are still there, still unexplained, still waiting for the kind of investigation that would tell us whether they are natural geological formations or the remains of something built by human hands. The offshore structures near Dwarka are still there, still documented in S.R. Rao's published work, still raising questions about the extent and age of the ancient port. The carbon-dated wood fragment is still in a laboratory somewhere, its date still extraordinary, its context still uncertain. All of these things are still present, still real, still unresolved, and the tools to investigate them exist. The methodology is established. The scientific questions are clear. What would be needed in the end is a sustained and properly funded research program, conducted according to the best available scientific standards, insulated as much as possible from the political and cultural pressures that have complicated the question so far, and committed to publishing its findings honestly regardless of what those findings turn out to be. Whether they confirm the presence of a human settlement 9,000 years old, or reveal that the sonar anomalies are natural formations, or produce something in between, something more modest in age but still significant, the honest answer would be more valuable than any of the claims currently in circulation. That honest answer is what the question deserves. And it is, in a way, what the site itself seems to be asking for, if you can forgive a slight anthropomorphism about a patch of murky seabed. Whatever is down there has been waiting a very long time. It waited through the rising of the sea, through thousands of years of darkness and sediment, through the development of the civilizations that would eventually build the tools to find it. It can probably wait a little longer, but the longer it waits, the more the sediment shifts, the more the tidal currents rearrange whatever lies on the surface, the more the window of opportunity narrows. And so the question of what it would take to properly investigate Dwarka is also, quietly, a question about priorities, about what we consider worth knowing, about whether the past is something we are willing to invest in recovering, even when the recovery is difficult and the answers are uncertain. The methods exist. The site exists. The question exists. What comes next is a matter of will, and of the kind of patient institutional commitment that turns a sonar image and a carbon date and a diver's hand running along a stone wall into something we can actually call knowledge. Which is, when you step back and think about it, what all of this has really been about from the beginning. And so we arrive, quietly, at the end of the question, not at its answer, because the answer has not yet been given, but at the place where the question itself settles into something you can hold for a while without needing to resolve it immediately. There is something worth sitting with in all of this. The sea does swallow cities. That is not mythology. That is not the wishful thinking of ancient poets trying to explain a world they did not understand. It is geology. It is oceanography. It is the documented record of what happened to coastlines all over the planet when the ice sheets melted and the water rose and the land that people had walked on for generations simply went under. Doggerland went under. The Persian Gulf floor went under. The Black Sea shelf went under. Dozens of sites around the Indian coast went under. The sea is not a respecter of human settlements. It never has been. It takes what it wants on its own timeline, and it keeps what it takes for a very long time. So when the Mahabharata describes the ocean advancing on the city of Dwarka, when Arjuna watches the water come in, and the streets and the gardens and the towers disappear beneath the waves, that is not automatically a fairy tale. It may be a memory, a very old memory, shaped by centuries of retelling, polished and mythologized, and woven into a larger story about gods and heroes and the nature of time, but with something real at its centre. The specific geography in the text, the western coast, the sea, the submersion, the timing, it fits. Not perfectly, not in a way that proves anything, but it fits in the way that a key fits a lock when you're not entirely sure which key you are holding. This is what makes Dwarka unusual among the world's submerged site controversies. It is not just an archaeological puzzle. It is a place where myth and geology and archaeology and oceanography all converge on the same question, from different directions, using different languages, arriving at roughly the same coastline. The texts say, a city went under the sea here. The geology confirms that sea levels rose dramatically here, that land which is now underwater was once dry coastal plain. The sonar images show anomalies on the seabed. The inshore excavations found real structures, real artifacts, a real ancient port. These things do not all fit together into a single clean story, but they do not contradict each other either. They orbit the same possibility. What makes a story survive for 3,000 years? That is a question worth asking quietly. The Mahabharata is one of the longest literary works ever composed. It contains battles and philosophy and genealogy and cosmology and moral argument. It is enormous. And within that enormous work, the submersion of Dwarka is not a passing detail. It is a specific event described with specific geography, attributed to a specific cause, witnessed by a specific named character. That level of specificity across that span of time is unusual. Stories that survive that long in that much detail tend to have some kind of anchor in experience, not always a literal one, but something. Some historians of ancient narrative argue that flood myths and submersion stories appear in cultures all over the world precisely because the end of the last ice age was a global traumatic event for human populations. Sea levels rose by 100 meters or more over several thousand years. Coastlines that communities had inhabited for generations simply ceased to exist. The people who lived through the early phases of that process, or whose ancestors did, carried those memories forward in the only way pre-literate and early literate cultures could carry them: in story, in ritual, in the names of places that no longer existed above water. The Mahabharata's account of Dwarka may be exactly that kind of preserved memory, not a literal transcript of events, but a cultural echo of something real that happened to real people on a real coast. That is a possibility worth taking seriously, not as proof, but as possibility. The modern city of Dwarka is still there. It sits on the western tip of the Saurashtra Peninsula in Gujarat, a small city of perhaps 100,000 people, busy with pilgrims and priests and the ordinary traffic of a living town. The Dwarkadish temple stands at its heart, a limestone structure that rises 5 stories above the surrounding streets, its spire visible from the water. It has been rebuilt and expanded over centuries, the current structure dating to the 16th century, though the site itself is claimed to be far older. Every day, pilgrims arrive from across India to offer prayers to Krishna, to walk the narrow lanes toward the temple, to touch the walls and stand at the ghats where the river meets the sea. The sound of bells carries across the water in the early morning. The smell of incense mixes with salt air. It is a place that has been continuously sacred for longer than most cities in the world have existed, and just offshore, the sea moves over whatever lies beneath it. The water is not particularly dramatic here. It does not announce itself. It simply continues, as it has continued, covering the seabed with its patient indifference, letting the tidal currents rearrange the sediment, letting the years pass. Somewhere beneath that water, the evidence of something is waiting. Whether it is the legendary Dwarka of the texts, or an older Bronze Age port, or a natural geological formation that fooled a sonar survey, or some combination of all three, it is waiting. Quietly, without urgency, the way things that have been underwater for thousands of years tend to wait. There is a particular kind of feeling that comes with places like this. It is not exactly mystery, though mystery is part of it. It is more like the feeling of standing at the edge of something you cannot quite see. You know something is there. The evidence points toward it. The stories describe it. The geology permits it. But the full shape of it remains just out of reach, below the surface, behind the murk, in the space between what we know and what we have not yet properly looked for. It is an uncomfortable feeling if you need resolution. It is a rather beautiful feeling if you can make peace with uncertainty. The question of Dwarka is, in the end, a question about how much of the human past is still out there, submerged and waiting. The answer, based on everything we know about sea level change and coastal habitation patterns, is quite a lot more than we have found. More than we have properly looked for. The world's coastlines have moved dramatically over the past 12,000 years, and wherever coastlines were, people were. Not always in large numbers, not always in complex societies, but people. Living, building, fishing, trading, telling stories. Much of that world is now underwater, and we have barely begun to look for it. Dwarka sits at the centre of that larger question. It is not just one site. It is a representative of a whole category of lost places that the sea has claimed, and that human memory, in various forms, has tried to hold on to. The texts, the myths, the pilgrimage traditions, even the name itself, Dwarka, the city with gates, the gateway, all of it points toward a place that people believed was real, that people mourned the loss of, that people kept returning to in story and in prayer across thousands of years. Whether or not the sonar anomalies in the Gulf of Kambat turn out to be man-made, that continuity of memory is itself remarkable. Cities that are lost and remembered are rarer than cities that are simply lost. And there is something moving about the fact that the modern city of Dwarka still stands where the ancient one is said to have stood, that people still come to the edge of the same sea that the texts say swallowed the city, that the temple bells still ring over the same water. There is a kind of faithfulness in that, a long, slow faithfulness that has outlasted empires and dynasties and the shifting of coastlines. Whatever was here, whatever went under the sea, it was important enough that people kept coming back to the place where it had been. That tells you something, even if it does not tell you exactly what. So where does that leave us? Honestly, it leaves us in the right place, which is not with a neat answer, but with a genuine question, properly understood. The inshore excavations near Dwarka produced real evidence of a real Bronze Age port, dated to around 1500 BCE and possibly older. S.R. Rao's work was careful and published and peer-reviewed, and it stands. The offshore structures at 5 to 12 metres depth, the walls and bastions and triangular anchors are real finds, more modest in their claims than the Gulf of Kambat, but more scientifically defensible. The Gulf of Kambat sonar anomalies are real anomalies, genuinely unexplained, possibly natural, possibly not, and the carbon-dated wood fragment is a real datum, even if its context is compromised by the dredging method. None of these things have been properly resolved. All of them deserve better investigation than they have received. What we can say with confidence is that the Arabian Sea off the coast of Gujarat has swallowed land that was once inhabited. The sea level history makes that certain. We can say that Dwarka was a real ancient port, active during the Bronze Age, with trading connections across the region. We can say that the texts describing its submersion are specific enough to suggest some basis in observed reality, even if that reality has been transformed by centuries of mythologization. We can say that the Gulf of Kambat contains sonar anomalies that have not been satisfactorily explained by either side of the debate, and we can say that a proper scientific investigation using the methods and standards that exist today has not yet happened. Everything beyond that is possibility, and possibility, honestly, is not nothing. It is the space where the next discovery lives. As evening comes to the modern city of Dwarka, the light changes over the water. The Dwarkadish temple catches the last of the sun, its limestone spire going gold, and then amber, and then a pale grey as the sky deepens. The pilgrims begin to move toward the evening prayers. The bells start again, low and resonant, carrying across the ghats and out over the water where the river meets the sea. The sea itself is quiet at this hour, just the soft push and pull of the tide, the small sound of water against stone, the same sound it has been making here for longer than any record can say. Somewhere beneath that water, something waits. Maybe it is the city of the texts, the golden city built in a single night, swallowed in a single tide. Maybe it is something older, or something younger, or something that does not fit neatly into any of the stories we have told about it. Maybe it is a geological formation that will, when properly examined, turn out to have a perfectly natural explanation, and the mystery will quietly resolve itself into science. Or maybe, when someone finally goes down there with the right tools and the right patience and the right commitment to honesty, they will find something that changes what we thought we knew about the depth of human history in this part of the world. We do not know yet. That is the true answer, and it is not a disappointing one. It is an open door. If you have made it this far, I would love to know what you think. Do you believe there is something real beneath the Arabian Sea here? Does the convergence of myth and geology and archaeology feel compelling to you, or do you remain skeptical? Leave a comment. These conversations are genuinely one of the best parts of making these videos, and I read more of them than you might expect. If tonight's journey was the kind of quiet, curious company you enjoy, a like on the video helps more than you might realise, and subscribing means you will find your way back here the next time we go looking for something the world has half forgotten. There are more places like this, more questions like this, more stories that have been waiting patiently at the edge of what we know. For now, let the bells carry you out. Let the sea do what it has always done, moving quietly over whatever it holds, keeping its own counsel, indifferent to our questions but not, perhaps, entirely beyond our reach. Sleep well wherever you are listening from. The water will still be there in the morning,